صوت شغال؟ شغال؟ Can you hear me well?
Yes.
Yeah. Well, welcome to the inaugural Symposium on Logic in the Arab World. We will start with opening remarks from the Department Head of Philosophy at Kuwait University, Dr. Al-Zawawi. So Dr. Al-Zawawi is going to give an opening remarks in Arabic, and then Dr. Misfer Al-Hayani is going to translate for us.
شكرا دكتور راشد. فاضلة الدكتورة ليلى الموسوي رئيس التنفيذي لمؤسسة الكويت للتقدم العلمي، ضيوفنا الأساتذة والباحثين القادمين من مختلف أرجاء العالم، زملائي أعضاء هيئة التدريس بقسم الفلسفة، طلابنا الأعزاء، أرحب بكم في مؤتمرنا العالمي الأول للمنطق في الوطن العربي، والذي يشارك فيه نخبة علمية متميزة ستعكف خلال 3 أيام على مناقشة قضاياه ومسائله الدقيقة التي ستشكل إسهاما جديدا في بناء صرح المنطق الرياضي الذي يعد كما نعلم الوجه الجديد لتطور الفلسفة في عصرنا. والحق فإنه إذا كان المنطق يشكل عماد التفكير الفلسفي، فإن أشكاله المعاصرة قد تتجه نحو الاستقلال عن الفلسفة، وبخاصة الفلسفة العملية. ولكن ما تطرحه هذه الأشكال والنظريات والمقاربات المختلفة قد عزز جانبا مهما من السؤال الفلسفي الذي نجمله في مبحث فلسفة المنطق، التي ستكون إحدى المحاور التي يثريها هذا المؤتمر العلمي الذي ما كان لنا أن ننظمه في قسمنا لولا المساعدة الكريمة التي قدمتها لنا مؤسسة الكويت للتقدم العلمي، التي نتقدم إليها بأجزل عبارات الشكر والتقدير. كما أتقدم بخالص الشكر إلى الرئيس العلمي للمؤتمر الزميل العزيز الدكتور راشد أحمد، الذي عمل بجد واهتمام وشغف قل نظيره في إعداد وتنظيم هذا المؤتمر العلمي العالمي للمنطق في العالم العربي، والذي نعده علامة متميزة في نشاطنا العلمي لقسمنا وكليتنا وجامعتنا جامعة الكويت التي تسعد باستضافة هذا المؤتمر. وشكرا والسلام عليكم.
Okay, good morning everyone. Dr. Layla Al-Musawi, our esteemed guest professors and researchers joining us from different parts of the world, my colleagues, the Department of Philosophy, our dear students, distinguished attendees, I warmly welcome you to our symposium on logic in the Arab world. This symposium brings together an outstanding group of scholars who will dedicate 3 days into discussing issues and questions in logic. These discussions will undoubtedly contribute to the ongoing development of mathematical logic, which, as we know, represent a new phase in the evolution of philosophy in our time. Indeed, while logic has always been the backbone of philosophical thought, its contemporary form seemed to be moving towards independence from philosophy, particularly from practical philosophy. However, questions, theories, and diverse approaches that these forms introduce have been strengthened an essential dimension of philosophical inquiry, namely the philosophy of logic, which will be one of the key themes explored in this academic symposium. Organizing such an event within our department would not have been possible without the generous support from the Kuwait Foundation for the Advancement of Sciences, to whom we extend our deepest gratitude and appreciation. So thank you again, Dr. Layla Al-Musawi. I also express my sincere thanks to my dear colleague, Dr. Rashid Ahmed, the Symposium Scientific Chair, whose dedication, effort, and exceptional enthusiasm have been invaluable in preparing and organizing this global symposium on logic in the Arab world. We consider this symposium a prominent milestone in the academic activities of our department, our college, and Kuwait University, which takes a great pride in hosting this event. So, thank you, everyone.
Many thanks, Dr. Al-Zawawi Baghura and Dr. Misfar Al-Hayani. I just want to give a quick talk. I would like to emphasize our immense gratitude to the Kuwait Foundation of the Advancement of Sciences for their generous support. Additionally, this symposium would not have been possible without the amazing work of our department head, Al-Zawawi Baghura, and Rania Al-Jayzawi, the Secretary of Philosophy Department, and Fatma Al-Nasser, the Secretary of the French Department. They worked day and night to make this symposium a reality. I would also like to express our sincere appreciation to the keynote speakers, Graham Priest, Gillian Russell, Eduardo Barrio, and Suki Fen, for accepting our invitation. I'm excited to learn about uber-consistent logics, logic for virtual worlds, inconsistent validity, and nothingness. This symposium would not be complete without the dedicated contributions of our speakers. I am incredibly grateful for your contributions, and I cannot wait to hear more about your works and ideas. I think it's truly beautiful that we are gathered here because we share the same passions. Our passion for the pursuit of truth and knowledge, and of course our passion for logic. I am confident that we will have many fruitful discussions, collaborations, and long-lasting connections. I hope that this symposium will pave the way to more conferences dedicated to logic in the Arab world. Without further ado, I am pleased to introduce our first speaker, Ryan Simonelli. Is that correct? Okay. Who's going to give a talk titled Yes, No, Neither, and Both.
This like this?
Yeah.
Okay. Okay. All right. Awesome. This one. Oh.
Just a second. Try now.
All right.
Well,
Thank you.
thank you.
Thanks everyone
for hosting this and
having me. My talk's
my talk's called
Yes, No, Neither, and Both.
That's sort of a play on Ian Rumford's Yes and No. And I'm going to be talking about bilateralism, bilateralism in the philosophy of logic. Here's Timothy Smiley. The idea is to treat assertion and rejection as distinct speech acts on all fours, right? And specifically, the thought is that asserting not P, it might be inferentially equivalent to denying P or rejecting P, but these can't be understood as the very same thing. Any more than asserting P and Q is the same as asserting P along with asserting Q. Here's Ian Rumford expressing the same thought. The acts of accepting and acts of rejecting, answering a question affirmatively, answering it negatively, saying yes, saying no, those are to be conceived of on all fours. Here's Greg Restall. He says the speech act of denial is best not analyzed in terms of assertion and negation, as Frege famously says, but rather denial is in some sense prior to negation. And here is David Ripley elaborating on this idea. He says we can give an account of classical negation as follows. Negation not A is assertable just in case the negatum A is deniable, and not A is deniable just when A is assertable. So here's four different expressions of this bilateralist idea. But they end up getting spelled out in two different ways. Smiley and Rumford spell out bilateralism in one way, Restall and Ripley spell it out in another way. I'm going to end up talking about both of these, but let's start with the Smiley-Rumford style bilateralism. So the idea is to provide bilateral proof systems in which formulas are positively or negatively signed, expressing these opposite speech acts of assertion or denial. And I'm just going to talk in terms of assertion and denial, but substitute your favorite pair of opposite notions. So we'll have signed formulas plus A indicating assertion of A, minus A indicating the denial of A. And note that these signs aren't logical operators. And by this, you can think of them, they're not embeddable. So these things are well formed. This expresses the assertion of P and not Q. That's the denial of P. These things are not well formed. You can't embed the signs. And using this sort of notation, Rumford says, here are rules for negation. Denying A is the same in the sense of being inferentially equivalent to asserting the negation of A. Asserting the negation of A is the same as denying A. Asserting A is the same as denying the negation of A. So these things are the same in the sense of being inferentially equivalent to, but they're not identical. Okay, so using this bilateralist idea, Rumford puts forward a natural deduction system. Just take Genson's rules for assertion, for conjunction and disjunction. Here, the phi is an arbitrary sign formula. Supplement them with corresponding rules for denying, along with those negation rules that I just showed you. And these are the operational rules of his natural deduction system in the paper. And using just these rules, you can prove some things. For instance, you get the Morgan's laws. But using just these operational rules, not every classical validity is provable. For instance, you don't get the law of excluded middle or explosion. So Rumford supplements these rules with what he calls coordination principles. And these are kind of structural rule that coordinates the opposite stances of assertion and denial. So Smiley and Rumford, they use this sort of rule. This is called Smiley and reductio. And the idea is you can assume some assertion or denial, some sign formula phi, if you get a contradiction in the sense of both some formula and its opposite, so assertion of some formula and denial of that formula, then you can conclude the opposite of the thing that you assume. Pedro de Valentin notes that this is actually equivalent to the following two rules. This sort of breaks down what's actually going on here a little bit. Here you have bilateral excluded middle, which says if you assume some sign formula and you conclude some sign formula from that, and you also conclude that thing from the opposite, then you can conclude that thing. Bilateral exclusion says if you have both some formula and its opposite, then you can conclude anything. And just once again, note, these rules are like structural rules in that they don't involve any logical connectives. But they're not structural rules in the sense that they concern the structure of a consequence relation. Rather, they concern the structure of assertion and denial. Okay, and Rump sort of just says, look, we want classical logic, so we're going to impose some sort of structural rule to get us all the classical stuff that we want. And this does the trick. We get all of the classical stuff using these coordination principles. Okay, but there are certain circumstances in which we might question these coordination principles. So consider the following sentence. Lambda is not true. Is lambda true? We're all familiar with this. Seems like if we say yes, we commit ourselves to saying no. If we say no, we commit ourselves to saying yes, right? So if we assert, we commit ourselves to denying. If we deny, we commit ourselves to asserting. So what should we do? Here I take it at two possible responses. We could say neither yes nor no. Neither assert nor deny. Or if we're going to say either, we have to say both. So we say both yes and no. So if we opt for one, we should reject this coordination principle of excluded middle. This sort of imposes this idea that assertion and denial are exhaustive. You always have to be able to take one of them. If we opt for two, we should reject exclusion. That sort of imposes the idea that assertion and denial are exclusive. It's never correct to take both of them. And if we think both and one are powerful, maybe we'll reject both answers, both the coordination principles. Okay. So here's a question. Rump proposes this bilateral system with these bilateral operation rules and these coordination principles. Well, what do we get if we drop one or both of these coordination principles? The answer is that we get the bilateral version of some familiar logics. So here's a sort of standard approach to four-value semantics. We let the valuation of sentences be the sets containing 1, 0. So we have the empty set just containing 1, set containing 0, set containing 1 and 0. These are the familiar semantic clauses. I'm not going to go through the detail, but they're just sort of standard semantic clauses. And you have an argument that's valid just in case it preserves truth in the sense that there's no valuation such that all of the premises are true and conclusions untrue. And defining things in this way, we get the following logics. We get FDE, which allows both gaps and gluts. K3, which allows gaps but excludes gluts. LP, which allows gluts but excludes gaps. And classical logic is just what we get if we exclude both gluts and gluts. Okay, so this is just sort of familiar stuff. We can sort of generalize this idea of bilateral validity so that we get bilateral versions of all of these logics. So we'll say that asserting some sentence A is correct, just in case A is true, and denying the sentence A is incorrect, just in case A is false. So some sentences, if they're neither true nor false, are neither correct to assert nor correct to deny. Some sentences may be both true and false, so both correct to assert and correct to deny. Officially, we'll say that asserting a sentence is correct, just in case 1 is in the valuation of that sentence, and denying a sentence is correct, just in case 0 is in the valuation of that sentence. And here we just define bilateral validity. This is what Rump calls smiley validity. And the idea is that here gamma is a set of sign formula and phi is a single sign formula. Gamma terms phi is valid, just in case there's no valuation such that all of the premise stances are correct and the conclusion stance is incorrect. And note it sort of follows directly that the positively signed fragment of bilateral validity consequence relation corresponds to standard unilateral validity relation. Okay, so here's the first sort of fact. If you take just the operational rules of Rump, you can get a bilateral system for FDE. If you take the operational rules and bilateral explosion, you get a system for K3. If you take the operational rules and exclude the middle, you get a bilateral system for LP. And taking both of these coordination principles, you already know, this is classical logic. Okay, and these systems are symmetric with respect to bilateral validity. Okay. You can also do the same sort of thing with calculus. So here's a single conclusion bilateral sequent calculus. The rules are, so in a sequent calculus, rather than introduction and elimination rules, you give left and right rules. These rules are sort of pretty natural, what you would expect. And once again, this is the system for bilateral FDE, for bilateral K3 at explosion, bilateral LP at extreme middle. Adding both, you get classical logic. Now, it's often illuminating to generalize to the case of multiple conclusions. And this can be done in a sort of straightforward, intuitive way. So gamma turnstile delta, right, these are sine formulas, is valid just in case there's no valuation such that all of the speech hacks in gamma are correct, and all of the speech hacks in delta are incorrect. And so here's a sort of generalized version of bilateral explosion and excluded middle along multiple conclusions. And given reflexivity and cut, these structural rules and the consequence relation, these are equivalent to the following axiomatic versions of bilateral explosion and excluded middle. This sort of nicely gives you the sort of duality of these pairs of principles. And they're also equivalent to these rules. You can do the same thing in this way. I'll cover this first one in and the second one out. So this says if gamma turnstile some sine formula conclusions, then you can push the formula to the other side of the turnstile and star it. This lets you push it the other way and star it. Okay. And here are four multiple conclusion sequent calculi. So these are quite nice. And once again, you get bilateral versions of these logics by adding the coordination principles. Okay. So this is just sort of technical stuff. But there's a sort of very straightforward way of thinking about the bilateral version of these logics. And you have natural deduction system, single conclusion, sequent calculi, multiple conclusion, sequent calculi. Okay. Here's the sort of philosophical point, and at least the one I'm going to be talking about here mainly. Moving from unilateral consequence to bilateral consequence has important philosophical consequences, and particularly for how we think about the relationship between what's called substructural and subclassical approaches to semantic paradox. Okay, so I've been talking about Smiley-Rumpet-style bilateralism. Let's switch gears and talk about this other form of bilateralism posed by Greg Restall and developed by Dave Ripley. And here the idea is that rather than developing a proof system in which formulas are positively and negatively signed, let's use bilateralism to interpret standard multiple conclusion sequent calculus. So here X and Y are sets of sentences, and you read a multiple conclusion sequence as saying that asserting everything in X along with denying everything in Y is incoherent or out of bounds. Here's another gloss of the same thought, right? There's no way for it to be correct to assert everything in X and deny everything in Y. So we can actually just sort of translate this into sign notation. Remember in our sort of way of thinking about bilateral sequence, where gamma is a set of sign sentences, gamma turnstile says that it can't be the case that all of the stances in gamma are correct. And so we can translate a multiple conclusion sequence of the form X turnstile Y, interpreted in this bilateral fashion, to a bilateral sequence of the form gamma turnstile. Just positively sign everything in X, negatively sign everything in Y, and throw that into gamma, and then stick the turnstile on there. Okay. So here is the classical sequent calculus. This is the sort of sequent calculus that Restall develops this bilateral interpretation to make clear. He says, look, they have these multiple conclusions. This is an essential feature of how this works. How do we interpret it? Well, in this bilateralist way. Now, here is the solely left-sided fragment of bilateral K3 or bilateral classical logic under the translation schema, right? So these two things are the same, it's just one's translated. here's a question. Should we think of the classical sequent calculus as the solely left-sided fragment of bilateral K3 or bilateral classical logic? Here's the fact. The solely left-sided fragments of bilateral K3 and bilateral classical logic, they completely align at the inferential level in the sense that you have the same set of valid solely left-sided sequence, but they diverge at the meta-inferential level. OK, and this will be relevant when we consider the main sort of purpose of Ripley's development of this bilateral reading of multiple conclusion sequence. And this is to make plausible a particular solution to the liar paradox and other semantic paradoxes that involves the rejection of cut. So cut is a standard transitivity principle in a sequent calculus. Here is unilateral cut, right? Here, A is a sentence, and X and Y are sets of sentences. The bilateral reading of this says if relative to some position, right, consisting in asserting everything in X and denying everything in Y, asserting A is out of bounds, and relative to that same position, denying A is out of bounds, then that position is itself out of bounds. So Restall speaks of this as an extensibility principle. The idea is any coherent position is coherently extendable to either the assertion or denial of any sentence. And Restall and Ripley sort of says, look, if we think about the liar paradox, it's plausible to call this rule into question, right? We might think that the liar is such that it's always incoherent to assert it, it's always incoherent to deny it, but that doesn't mean that every position is itself incoherent. And technically, rejecting cut, you can accept the sort of transparent truth rules and the negation rules, but rejecting cut, you block this triviality proof at the final step, right? So here, X and Y are arbitrary. This would let you conclude anything, but you block cut. You block this proof at the final step by rejecting cut. OK, but now, given the translation scheme above, we can sort of make this bilateral approach explicit in the notation itself. Using this translation schema, cut ends up being the following principle, which I've just labeled extensibility. This says exactly what I just said. The standard version says on the bilateral interpretation. Now this is explicit in the notation. And this just is the solely left-sided instance of bilateral excluded middle, right? This is bilateral excluded middle. You just have a formula or set of formulas on the right-hand side. But this is the same principle. So bilateral K3, which accepts bilateral explosion but rejects bilateral excluded middle, blocks the following proof at the final step. This is the very same proof I just showed, just translated. This is bilateral K3 blocks it at the final step. So here's the claim. This solution, the substructural solution to the liar paradox that Ripley proposes, once it's recast into this explicitly bilateral setting, right? Once we make his bilateralism explicit in the notation itself, we see this is really just the solution of bilateral K3. We're just restricting our attention to the left side of the turnstile, right? Where this is codifying incoherences. OK. It's not hard to see sort of semantically that this is in fact the case. So here's K3 validity, right? We have the set evaluations for K3. K3 validity is truth preservation across this. And we know that bilateral K3 aligns with K3 in its positively signed fragment, right? But we might also use the same set of evaluations to define a different notion of validity, ST validity, X turnstile-wise ST valid, just in case there's no evaluation in K3 such that 1 is in the valuation for everything in X, and 0 is in the valuation for everything in B, right? So this you can take the same set of evaluations and define this other notion of validity. This is the notion of validity that Ripley appeals to sort of reject cut. And recall, right, there's no, we have gamma turnstile just in case there's no evaluation such that all of the X and gamma are correct. We have, oh, there should be a plus here. Plus X, comma, minus Y.
just in case there's no evaluation in K3 such that 1 is in evaluation of A for all A and X, and 0 is the evaluation for all of B and B. So, well, bilateral K3's positively signed fragment is that of K3. Its solely left-sided fragment under the translation schema is just that of ST. Sorry, yeah, this X should be a plus. Here's a side note. If you look at the solely left-sided fragment of bilateral LP, that's just bilaterally interpreted TS. Just note that. So by translating into explicitly bilateral notation, we can extend Ripley's solution to the other side of the turnstile, such that we don't just talk about incoherences, but we also talk about committive consequence relations. So specifically, take a look at the following principles. Here is the single conclusion version of this principle I call out. So this says if gamma along with some speech act phi is incoherent, then gamma commits you to the opposite of that speech act. And if you're a proponent of Ripley's approach to the liar, you should reject this because you think the liar affirming the liar sentence is always incoherent, but that doesn't mean you should deny it, right? That's incoherent too. Here's another principle. This says if gamma commits you to some speech act, then gamma along with the opposite of that speech act is incoherent. And if you have this sort of approach where you think, well, assertion and denying the same thing is always incoherent, you should accept this. Bilateral at K3 rejects out and accepts in. So once again, in this way we can formally represent aspects of the informal reasoning that's left implicit on Ripley's approach, talking about both incoherence and consequence. Okay, I'm running out of time, Ripley advertises his approach as one that enables you to retain all of classical logic. In one sense, this is true. All of classical logic is there on the left side of the turnstile. In another sense, this is false, because all of bilateral classical logic isn't there in bilateral K3. And Ripley claims that his approach is substructural. It requires us to let go of the transitivity of consequence. In one sense, this is true. We have to get rid of unilateral cut, which, as translated, is this principle of extensibility. But in a deeper sense, this is not true because the bilateral consequence of bilateral K3 is completely transitive. So we don't really have to give up transitivity for bilateral consequence. So whether an approach counts as substructural or subclassical depends on whether we're speaking of unilateral consequence or bilateral consequence. Okay, thank you, and that went really quick, so come talk to me after.
We have some time for a couple of questions. Federico?
Hi. So in the Smiley-Ramphey approach, so if you consider that approach and a sentence like the liar, that is neither correct nor incorrect, doesn't this sentence force to add a new force mark representing things that are neither right to accept nor reject? And probably if you do that, doesn't that also, this would be nice to have a force mark representing things that are both acceptable and deniable,
Yeah,
in order to make everything explicit at least.
Yeah, I mean, so another approach, right, to multilateral systems for logics in this family is a four-signed approach, right, where you have signs for assertion denial and a sign corresponding to neither and a sign corresponding to both. In some sense, I think this approach is a little nicer, right, because we just have assertion and denial, right? So the thought on which it's based is that asserting something is correct if that thing's at least true. Denying something's correct if that thing's at least false. So there's just the two speech acts of assertion and denial, and you can sort of give the proof systems for all of the logics in this family, just sticking in bilateral terms. And the thought is the only thing that differs between them is the coordination principles, right? Whether we think of assertion and denial as exhaustive or exclusive, right? And there's definitely close relations between these approaches, but I think this sort of approach where we just have assertions and denials So just 2 signs. There's some value in that.
Very good. We have time for one more question. Graham?
Yeah, that was nice. The difference between the one-side and the two-sided approach was really interesting. I'd never seen that before. If you dualize and do the corresponding thing for LP, it's kind of interesting because you also get something that I wouldn't have thought happened. Because if you dualize, you said you get TS, right? And that's kind of different from LP because TS is what you get when you, in the cut sequence, in the sigma calculus, you reject identity. And that has no logical truths, whereas LP, of course, does. So it also illustrates the way that the one-sided and the two-sided fall apart in a way that I find quite unexpected.
Yeah, so so the identity principle, right? I mean, so it's worth saying, right? These claims are couched in if you adopt this bilateral reading of the sequent calculus, right? And in that context, identity, right, corresponds to this bilateral explosion principle, right? So, you know, A turnstile A, translating that into the sort of sign sequence, that's, you know, plus A minus A turnstile, right? LP rejects that, right? Because, I mean, at least on bilateral LP rejects that because you might think asserting something and denying that very thing is correct. It's not always incoherent to assert and deny the same thing. And so that's why, yeah, the solely left-sided fragment of LP corresponds to TS. There's no solely left-sided sequence in bilateral LP.
What happens if you do the right side?
You can do that. It's just so all of these results, right, there's the dual, right? So it's just that interpretation is less philosophically clear than the solely left-sided interpretation, right? So you can do this, right? And so for instance, right, the solely right-sided fragment of bilateral K3 is also TS. It's just that this philosophical interpretation corresponding to solely right-sided sequence in this sort of system isn't, at least to me, nearly as intuitive as Restall's interpretation of the multiple conclusion sequence, which corresponds to the left-sided sequence, right? So it's something like the space of possibilities. I don't know, but yeah, all of the results are dual, obviously, yeah.
Let's thank Brian one more time. It is a pleasure to introduce Michalis Christou, who's giving a talk titled Contradiction and Inconsistency, Different but Still the Same.
So, thank you everyone, thank you for the introduction. This is an idea that I had, which is in its initial stage, and then I thought I might submit it and then share it with you and see where we can go from there. So generally, my work is in philosophy of science. I was looking into philosophy of science and especially in contradictions between theory and observation. When looking there, I came across these concepts in more detail. inconsistency, contradiction. So let's get to it. So some initial definitions that I have here. I define contradiction and inconsistency in terms of their truth values. So contradiction, we can take it as a pair of statements in which one is a negation of the other. And an inconsistency, on the other hand, is a pair of statements which cannot both be true, but both can be false. And of course, the prism of explosion, a set of propositions that's closed under classical logic is trivial if this set of propositions is contradictory, and then they explode to triviality. They can prove everything and anything, so this needs to be avoided, at least in classical logical settings. So my question I want to ask is a contradiction more serious than an inconsistency? But in what sense? So, initial answer in the literature that I've been looking at is yes. So an inconsistency is a weaker problem than contradiction. So in discussions about beliefs, we have Foley who says that this set of beliefs is inconsistent. It is logically impossible for all of them, for all of these set of beliefs to be true. However, there is no contradiction. So in his 1979 paper, he discusses contradiction and inconsistency regarding beliefs, but says that when we have inconsistent beliefs, still this is not as serious as having contradictory beliefs. Then we have the context of quantum mechanics, in which quantum superpositions, the multiple states that the quantum system is in before measurement, is an inconsistent situation, not a contradictory one. And this is argued, these ideas put forward by Arndt and Krause, and then they have this back and forth in a series of papers arguing in favor of this position. And especially in this paper, they mentioned that because it is an inconsistent situation, not a contradictory one, we need different ways of dealing with this thing. Now moving on to the history of science, we have inconsistencies in scientific theories. For example, Bohr's theory of the atom, in the early 1900s, is arguably an inconsistent situation. So, as Vickers points out, he presents some inconsistent cases in the history of science, and he says these are inconsistent, but nobody knew it for the best part of 100 years. The real challenge is to get from an inconsistency to a contradiction. So you can see that inconsistency and contradiction, at least in this case, is presented to different levels. And we need to get from one to the other in order to reach this contradiction. And lastly, Peter Strawson, he says that to say that two statements, that they are contradictory, is to say that they are inconsistent with each other and that no statement is inconsistent with both of them. To say that two statements that they are contraries, which means inconsistent, is to say that they are inconsistent with each other while leaving open the possibility that there is some statement inconsistent with both. And then he also mentions that he paraphrased, he says that seeing that two statements are inconsistent is the same as seeing that they cannot both be true together. So here I have two initial statements about consistency. The first being a theory is consistent if no pairs of contradictory sentences B, P, and not P are deducible from the theory. And then consistency star. A theory is consistent if no pairs of contradictory sentences P and not P can be deducible from that theory. So we can see that there's, actually we will see that there is a difference between these two, whether the contradiction is deducible or can be deducible. And what I want to get at is that if it can be deducible, then it is there. The contradiction is there. So, moving now to the philosophy of science part, especially the consistency between theory and observation. So, for the purposes of this talk, it will suffice to provide definitions of observation in these simplistic terms and of theories. Say we have theory T with expected observable O, but I don't know, after an experiment conducted, we actually observe not O. We observe the negation of O in a way. So the inconsistency here is that the theory was predicting to give observation O, but it turned out that it gave not O. So there are in philosophy of science literature, there are some examples regarding this inconsistency between theory and observation, and we'll move on to one of those, regarding the perihelion of Mercury. So in this case, classical mechanics predicted a certain value for Mercury's perihelion, which went against the actual observation. The calculated prediction of the precision was 5,557 semitoques per century. The actual observation was 5,600. So there was this discrepancy, this difference of 43 seconds of arc per century. And of course, many ad hoc fixes were implemented to see how and why this discrepancy was in place, but nothing could explain it at that time. So now, keeping in mind the perihelion of Mercury, I want to talk about a tangent issue regarding inconsistency and contradiction. So if we want to, let's say, tackle contradictions, at least as people in literature have tried to put forward the problem, if I have an inconsistency, it's a serious issue, but it's not as serious as contradiction, so I don't need to employ the same methods in order to tackle this issue in a classical logical setting. So the first thing to ask is, do the terms inconsistency and contradiction have the same implications? As I keep saying, people argue that inconsistency is weaker than contradiction. You will remember the discussion already discussed above. And of course, there is a case that sometimes we can see that contradiction is already confused with, here it says contrariety, but it's contrariety amounts with what I've been saying here. It's an inconsistency, so contradiction is often confused with inconsistency. And then we reach the situation where a pair of inconsistent propositions ought to be treated as contradictory and as having the same implications as a contradiction, which is what I will move on to now. Because if they have the same implications, then they should be treated the same. So in order for this thing to get going, there are some assumptions. So assumption is that in the philosophy of science aspect, scientists, at least to some degree, follow logical rules in their reasoning in order, of course, to avoid unwarranted conclusions. And drawing from Dewey, who, of course, said in a different setting, but for this in a different context, but the idea is similar. To engage in an inquiry is like entering into a contract. It commits the inquirer to observance of certain conditions. A stipulation is a statement of conditions that are agreed to in the conduct of some affair, and it is first implicit in the undertaking of inquiry. So the reason I put this slide here is because if I want to talk about the problem that contradictions or inconsistencies pose to a classical logical setting and reading of in philosophy of science, then we need to accept the, at least to some extent, the first thing pointed there, that scientists, at least to some degree, have to follow logical rules. So, very quickly, an example to differentiate between inconsistent and contradiction. We have these two sentences: the house is all green, the house is not all green. Of course, keeping in mind that in this case, the terms mean the same in both sentences. And then we have a different case, the house is all green, the house is all yellow. The first part is contradictory, so one is a negation of the other. The second one is not contradictory in the same sense, inconsistent, because we have the case that the house is all green, the house is all yellow. They cannot both be true if we're talking about the same house, but they can both be false if the house turns out to be another color. So there's this differentiation between contradiction and inconsistency. So now moving back to the perihelion. So we have P. The precision of Mercury's orbit is 5,600 seconds, and Q, the precision of Mercury's orbit, is 5,557 seconds of arc per century. So what I want to point out here is that I disagree that an inconsistency is weaker than a contradiction. And the reason for that is that I think that they have the same implications and therefore should be treated as being as serious, let's say, as a contradiction. So now we'll depart from these colors to get to the point at hand. So we would say that in this case, there is a contradiction between P and Q, a contradiction of the form P and not P, amounting to P and not P. Or is it a bit far-stretched? So the idea is that Q above essentially implies the not R, not S, blah, 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 and not P. So 5,557 implies not 6,000, not blah, 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 and also not 5,600 implies not P. So can we say that this is the contradiction, this is a hidden contradiction within this inconsistency? Yeah, and even though the contradiction is not seen in the first sense, in the first glance, is it there? So then we get into this conjunction. Q essentially implies not R, and Q essentially implies not S, blah, blah, and Q essentially implies not P. So not P is within Q. And here a nice artistic illustration. A person holding a ball and then another person holding an opaque closed box that we cannot see inside. And inside the box we know that there's a ball. Would we say that this person has a ball and that person does not have a ball just because we cannot see it? So this is the idea with the contradiction. Just because we cannot see it at the first glance, it doesn't mean that it is not there. So having P in the first three premises, P, Q, then number 3, Q essentially implies not P. Therefore, number 4, not P from 3. Number 5, P and not P from 1 and 4. So one objection that might be raised is that in the cases of inconsistency, we do not have a pair of propositions of the form of the clear form P and not P. What we have is this long conjunction, let's say. So we can consider the following, again with the houses. The house is all green in the first case. In the second case, the house is not all green and it is raining. The idea here is that when it has to do with the color of the house only, we have the case, even though there's this additional part of the conjunction, still the case is that in the one sense, in the one case, the house is all green, in the other case, the house is not all green. So in this case, they are contradictory. And even though the conjunction might get a bit bigger, still the fact of the matter is that we have P and not P within that conjunction. So still the contradiction takes place, and so I would say that is the case with the perihelion numbers. They are different, but within the difference, there is a contradiction lying there. So this captures the main idea behind this hidden contradiction, behind Mercury's perihelion. So the implication, if we accept that the contradiction is there, then the implication is the same. So the things I presented in the beginning about beliefs, mechanics, and history of science, where they say that one is less serious than the other. We can say that they are serious, so inconsistency is not less serious than contradiction, because an inconsistency hides a contradiction. And if it does hide a contradiction, then the implications be the same. Therefore, in dealing with these issues in a classical logical setting, at least in the philosophy of science, they should be treated in the same because of the same implication. So at least in relation to our discussion in this context, they ought to be treated as the same. I don't know if I have more time. I just went through it, but yeah, I have more time for. Thanks.
We have some time for some questions. Federico?
Hi. So I think that the notion of inconsistency is weaker in the sense that it depends on a mechanism to determine whether the sentences in the set can be both true. The contradictory is simpler in the sense that it's just a syntactic notion. You just need to check. And so that's one thing. And the other is that they might be the same, but in order to conclude that, you need to fix some logic or some way to inference from the set. So if it might be that given some logics, every inconsistent set hidden contradictions, but if you change the logic, that will no longer be the same. So they are the same relative to some given logic.
So thank you for that. I agree with the second part also. It's important, something I can maybe address in the future part of the talk. But for the first part, I can understand what you said, that they are not the same, which I also was a bit hesitant to call them the same, because they are not the same. But that's why I added this part about the implication, that they have like this implication, because I don't want to say that they are the same. I want to avoid saying that. And I want to see if it works with saying, to give this side road and saying that they have the same implication, at least in this context. But, yeah.
Any more questions?
Okay. Hello. Do you think we can use the classical square of opposition and the contrary and subcontrary with the contradiction to illustrate this, like for students? Because I thought that we can use it even to illustrate this problem. Mm-hmm. I know this is different, and we have in philosophy of science many examples, but I thought that even the square of opposition can illustrate this as well. Thank you.
Thanks. To be honest, in the initial part of the initial draft of the presentation, I had it as a slide, not to discuss it a bit. But then I was afraid that it might get a bit diverted. But maybe I should bring it back in order to discuss the definitions as given in the square of opposition, and then from there move on to this discussion about the kids.
We have time for one more question.
Thank you. So, two quick questions. One, when you say more serious, do you mean requires a greater degree of theory revision when it comes to the inconsistency between the expected observation and the actual observation? And secondly, is there a distinction on the way that you're approaching this in terms of inconsistency between a theory and an and the actual observation as opposed to the expected observation, and then the incompatibility of like premises within the theory or something.
So for the first part, there is in the literature, at least there is different methodology when someone is dealing with an inconsistency, let's say in the history of science or not, and when someone is dealing with a contradiction. So the idea is that in a classical logical setting, if you have a contradiction in the history of science, the idea is that maybe we should stop what we are doing in order to deal with that, to avoid explosion. Whereas for inconsistency, it seems that no, it's not the case that there is no explosion, but maybe we can work with it a bit until we see what we can do. So the idea is that in one you have to stop, whereas in the other we can work with it a bit, let's say, because it's not as serious, it does not lead to explosion as fast, let's say, or as directly as a contradiction. And sorry, what was your second? With the observation.
The difference between like cotenability or compatibility versus consistency between the actual observation and the expected observation.
So now I'm actually working on the term of observation as it pertains in science. So here, even though I presented a simplistic version of observation O and then not O, I think that this is an overly simplified way, and when we add the more a bit, I don't know, not complicated, but more detailed way of expressing an observation, then we can also discuss about what you said about incompatibility on the one hand, and on the other hand, was it inconsistency? So incompatibility. Consistency, compatibility. I've seen in the literature that sometimes they talk about incompatibility, but they mean inconsistency, and sometimes they treat them as differently. So in the first part, where they treat them the same, it just pertains to what I'm saying here. On the second part, it depends on the definition that someone provides about the compatibility and consistency. So if it's something, if incompatibility and consistency is not the same, if the definition given provides, if the definition provided treats them as differently, then I have to see what incompatibility amounts to. But in the literature I'll be looking at, sometimes they use the same definitions, but different words. So,
let's thank Michalis one more time. It's just for the Zoom to pick it up when you're far from the screen. But this one is necessary.
Okay. Turning to a soundboard.
You just share the screen.
Ooh, lasers. I'm going to get you started. All right. Can I just... Yeah, okay.
Oh, sorry.
Yeah, that's me, etc. All right. Cool. Thanks. And thanks, Rashid, for organizing this wonderful thing, wonderful conference. Bit of a warning. I got progressively worse at timing my talk, so this is basically twice as long as it should be. So I'm not going to finish. On the other hand, it's not so much a talk as an advertorial. So think of it as one of those super long YouTube ads. You've got two options. Either, hit skip right about when the pause is supposed to start, or get a paid subscription. I haven't worked out the details of the last option, but we'll make it work. So what do I want to do? In so many words, I want to look at some rules for the conditional in the context of calculi for logics which in one sense or another have tolerant consequence relations. That's all I want to do. I won't be doing this in this advertorial. I'm just going to look at some rules for conditional in the context of ST. The slides have been prepared for an audience who's, doing social philosophy and political philosophy and ethics, etc. So there's lots of details on them, but you all know what ST is, right? It's the strict tolerant consequence relation that Cobreros, Egre, Ripley, and Van Rooij defended as a way of dealing with the paradoxes. Now, there's a bit of a twist here. I'm going to look at these rules, which I think could be meaning determining, while at the same time focusing not on sequence as claims of consequence, but rather on the consequence relation between sequence in this calculi. I'm going to be looking at the meta-inferential consequence relation. And why do I want to do this? Well, I mean, generally ST is presented without the rules for the conditional, because you don't really need them, and why bother? But you could add them, right? So maybe you would want to add the standard rules for Gensen's LK. I mean, this is the empty version, but it doesn't really matter because you have weakening and contractions. So you might want to do that. But that's not the only thing you could do. You could have other rules for the conditional. You could have 8, at least, such rules. And this changes things. Now, depending on which logic you want to look at, it might be the right rule or the left rule that's more important. Since I'm looking at ST, it kind of makes sense to focus on the left rule. So, again, this is Gensen's standard rule, but you have options. And one option is Schroeder-Heister's left rule for implication as a rule, as opposed to link. That's a paper of 2013 of Peters, which makes this kind of nice distinction. And Peters' left rule looks a bit like this, right? If you get A out of X in some context, then you can get B in the same context out of A implies B and X. Just kind of funky, but it works. Now, it works with a bit of a twist. And that is that cut is not eliminable from this calculus, which is, again, if you think in terms of ST, which doesn't validate cut, looks a bit strange. So now you're going to start wondering, well, what happens if I add to my standard calculus for ST this rule, right? Which breaks down the admissibility of cut. Something fishy goes on. And here's when the cut eliminability breaks. Basically, whenever the left premise of cut is obtained by an application of the non-standard rule for the conditional. Now, the fun part is that although you don't get rid of cut with this rule, you still have the formula property, which is basically why you want to eliminate cut from a calculus. So the idea here is that this rule seems to be somehow connected with cut and with the transitivity of the sequent sign. Now let's see how much and how badly and what happens if I have it in my calculus. So first, let's look a bit at what the relation between the rules. It turns out that you can get Schroeder-Heister's rule out of the standard rule without cut, but you need cut if you want to go the other way around. And these are the derivations that show that. Okay, so do these different rules contain different amounts of cut? And if so, where would you expect that difference to be visible, right? How can you test for it? Well, I'm going to take a step back and look at some more left introduction rules for the conditional. I don't need to figure out which they are, because Michael Arndt did it for me, extending Peter's work in a 2019 paper in Studia Logica called 8 Inference Rules for Implication. And basically what he does is the modus ponens sequence, there shouldn't have been a bar above it on these slides, and then starts cutting bits and bobs in order to get rules out of it. And it turns out that you get 8 possibilities. Well, for instance, you could cut 0 times, in which you get the modus ponens sequence. You could cut 3 times, in which case you get that rule, which is basically cut turned up to 11. And that's a very funky rule, because it's neither purely operational, not quite structural, and of course you can't have it in ST, because all hell's gonna break loose. Then with 2 cuts you get cute things like the external modus ponens, or the inverse of the right introduction rule. So you may already notice, might already have noticed that not all the rules which you are getting are going to be sequence calculus introduction rules. Some of them are going to be eliminations, but that's fine, because I already have eliminations in the calculus for ST that I'm going to use, and which I'll show to you in a bit later, and all sorts, where's the back one? All sorts of other cute things. So you also get Jensen's original rule, you get 1/2 of the additive, no, you do get that too, but I can't see where. Anyway, you get fun rules, thanks to Michael's work. Okay. So not all of them are introductions, right? So you get 1 elimination list, then you get that bizarre thing with 3 premises, and you don't need to go through all of them, because you already know some things. So for instance, this one here, which is an elimination, is basically the inverse of the right introduction rule. In the classical calculus, it's derivable. If you don't have cut and identity, you can nonetheless show that it's admissible in classical logic. It's going to stay admissible in ST. It's going to stay admissible in TS. It will also be admissible in whichever calculus you use to represent FDE. Because just like Ryan's bilateral calculi, I'm going to go through a family of calculi that can express all these logics in the FD family, and in fact a lot more if you tweak your structural rules appropriately. That's work done by Adam Prenosil in another 2020, I believe, no, 2017 paper in Studia Logica. Okay, so what happens if I chuck these rules in ST? I don't know. I haven't done the work. As I said, this is a tutorial. But you know, I know some things about this. So this is just a review of ST, or really the logics in the family. But again, I'm going to look at this as meta-inferential calculus. When I say consequence relation, I mean, well, which sequence follow from which sequence. In a certain calculus, which looks kind of like this, I take a mixed additive multiplicative set of rules for conjunction, disjunction, and negation. I enrich that with the inverses of the introduction rules, serving as eliminations. Everything's nice and symmetric, left and right, and then I have weakening and contraction. This is the base calculus. Turns out that I can add identity to this calculus, or cut, or both of them, or nothing. And depending on what I do, on the sequence-to-sequence picture of consequence, well, no identity, no cut, I get FDE. If I add identity, I get LP. With cut, I get K3, so strong training logic. With both of them, I get classical logic. So now let's do that thing, right? So we take this calculus, and we look at some of the rules for the conditional, which we could add, while at the same time adding some elimination rules for the conditional. And the recipe is as simple as it gets. Just try to use the inverses as eliminations. You don't need to do that. You could have other kinds of eliminations, but the inverses are convenient. And if you wonder, well, why do you want the eliminations? Well, you want them first to get completeness. And really what they do, they take over a sort of side effect of having cut at hand. They act as a sort of complexity reducing mechanism for sequence, which is a side effect of some applications of cut. But unlike cut, which does that nuclear style, the eliminations will do it in a controlled fashion locally only where you need it and without overspilling in the entire calculus. So there's various things you could do with these rules. You could run them through the canonical model for the logics in this family. But we are philosophers, we care about metaphysical questions, so we're going to do proof theoretic semantics with this. So basically what we're going to do is check if these are harmonious in some sense. Which sense? Well, you need to figure out what's harmony for a sequent calculus that doesn't have identity, potentially doesn't have cut, has introductions and eliminations, and elimination rules. No worries, I got that sorted out for you together with Paoli in a paper that should be forthcoming this year in Ergo. So basically, we say for reasons, a set of rules in the sequent calculi in the family that I just showed you is harmonious if and only if it doesn't break down a certain normal form for derivations in that logic. And that normal form is the one that you get when for every derivation in the calculus you can replace it or reduce it to a derivation of the same sequence, the same conclusion sequence from the same premise sequence in such a way that in the reduct derivation every application of an elimination rule precedes every application of an introduction rule, and no structural rule is applied to a molecular formula. This we call structurally atomic analytic synthetic proof or derivation. So basically your proofs, derivations, I've used them as synonyms, are going to look like hourglasses. Right? There's a sort of wide top part in which you apply eliminations, you break things down, and there's a sort of widening bottom. There's a middle part in which you contract, cut, weaken, etc., only on atoms, and then there's a sort of widening lower part where you apply the introductions. I mean, this should be familiar as a form of derivations from Kravitz's normalization theorem for natural deduction. Can you do that? Oh yeah, and there's some philosophical argy-bargy about, what's this kind of harmony, and is it unidimensional or pluridimensional, and how does it connect with semantic values, and etc. That's just for, advertisement, basically. We don't care about the philosophy now. This is how your proofs look like. Right? Elimination, structural rules, introduction rules. Good. More advertising. And now let's look at the rules per set. Right? So we start with what? Oh yeah, we start with Gensen's rule, set of rules basically. So both the right introduction and the left introduction, I add suitable eliminations, which are just the inverses, and I go see if this would be a harmonious addition. Well, yes, it is. Because I can both, I have both the ingredients that allow me to prove the normal, to find the normal form reader of any derivation involving these rules. In particular, I can make sure that there is no introduction followed, there's no introduction applied before an elimination, and I can also restrict all my structural rules to atoms in the usual way. So to show that introductions and eliminations can be rearranged, you basically use the sequent correspondence of Kravitz's reductions in the proof of normalization for natural reduction, which is what you see here. And then you just look at what happens at the interplay between these rules and the structural rules. So for instance, if I have a sorry, I'm dying a bit. Not completely. If you want to see how you can get rid of a contraction on a conditional, well, here's the very mathematically complex operation that you need to do, right? You just trade that for two contractions on the antecedent and consequent, respectively, and then you just reiterate that till you hit atoms. If you want to see what happens with identity, well, the same thing, except I'm lazy and I couldn't be bothered to write two derivations there, so there's a slash between the bottom bits of this derivation, marking the fact that these are two distinct derivations. What happens if you take Peter-Schroeder-Heister's rule? Well, first you need to find a way to eliminate it. Easy peasy. You just read the rule from bottom to the top. And again, it's vertically harmonious, i.e. you can rearrange introductions and eliminations in such a way that all the eliminations are coming before any introduction. Now you'd expect the case of cuts to be a bit tricky because you can't really eliminate it, but it turns out that if you have the inverse as an elimination, that basically does the job that you want, and you can in fact reduce the complexity of your count. Because, as I said, the elimination rule is going to do the part of cut's job that you really care about. Again, weakening and contraction are completely unproblematic. Right. So, also you can check that, in the canonical model that the rule and its inverse are valid in history. So now let's look at the rules that look like eliminations rather than introduction. And this is the part where it makes sense to look if you can still, if you get completeness, right? Because think of the initial picture. On the initial picture, you are supposed to have left introductions, right introductions. And then you are also supposed to enrich the calculus with corresponding eliminations. But on this picture, on the other hand, you wouldn't have left introduction. Right? Your left introduction, for instance, would be replaced by the inverse of the right introduction. So the question is, well, is that enough, to prove that these calculi are sound and complete for the semantics that you are using, which is just a version of the done semantics for FD and the logics in the family. I'm not going to tell you the answer to that. I'm just going to carry on looking at whether these rules are harmonious or not. So that one's perfectly fine. I already told you that it's in fact admissible in all of these calculi, and in the classical one is also derivable. Now, this one is, we all know, is not good because it's the external modus ponens which famously fails in ST. Because reasons. Now these are again, but nonetheless, let's look a bit at what we can do for it. You know, we can add inverses of it there, and then you get, you know, half of the additive right introduction rule. That's what's his name? Ketonen's rule for the classical conditional, which breaks everything down. And then you have the final rule, the eighth rule, the one that you get via via two cuts. Now this is basically just the external modus ponens followed by an application of cuts. So again, it's not going to be ST valid. The question is it harmonious? Well, and I'm translating what I just said for my Argentinian friends, who might prefer to call that rule meta-explosion or something like that. Well, look at what happens if you try to invert it and to use the inverses as eliminations, assuming that it makes sense to do that. What you get are basically instances of weakening, which is kind of interesting, but it also breaks down the rearrangement of proofs, of rule applications in a proof, because there's stuff that disappears here, which you might need, and depending on what happens with X and Y, in particular, if X and Y contain other conditionals, other implications, things may get unpleasantly high. On which happy note, I'm done. Thank you so much.
We have time for some questions. Anyone? Eduardo?
Oh, sorry. Asking questions.
I am going to be famous here. I really enjoyed the talk, and in a way, is the result are the strategy that we ST, SLP, blah 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 blah. But could you connect this result with the first presentation with ST is K3 or something?
K3. So speaking of connections, I mean, half of these ideas, or rather the idea of looking at conditionals, is actually coming from a talk you gave in Lisbon,
yeah, Lisbon,
4 years ago, apart from all the other stuff that, you know, why give credit when credit is due. There are some connections there. I didn't know Ryan's work so far, but what he seems to be doing is to be using a version of, I think it's Blamey's translation between signed bilateral calculi and multiple conclusion sequence calculi. If he's not Blamey in the 70s, then Lloyd Humberston's The Revival of Rejective Negation is going to tell you exactly who's the author that I had in mind. So you seem to be using a tweaked version of that designing translation and signing translation, particularly when you do stuff on the left. Okay, so that's the technical correspondence. Otherwise, yeah, there is a connection. So what we are doing with Paoli in the paper about harmony, because we need to do two things. Tell you what's the formal measure for harmony and tell you why that is harmony as opposed to something else. And what we do, we develop exactly the same type of calculus, of interpretation of the calculi, so a sort of bilateral interpretation that drops the pragmatic consistency assumption, which Graham really likes, because Graham used not to believe that you can both assert and deny the same sentence. I think you didn't change your mind. So we sort of drop that, taking our cues from Belknap's how a computer should be. And on that picture, you end up, just like in Ryan's case, with a different take on what's cut and identity. And cut and identity are just, well, I say, how do I call them? Sui generis proof resources. Right? They have nothing to do with transitivity or reflexivity. They are just things that tell you, for instance, how your assertion and denials behave. And depending on how you interpret the calculus, whether broadly to the left, which, if I'm not wrong, means that you take your left comma to be a conjunction and the right comma to be a disjunction, you get a certain picture of which of cut or identity expresses exclusivity and which expresses exhaustivity. But I think if you were to do your calculus with the interpretation on the, with all the formula on the right, at some point you'd have to reinterpret your commas, and the premise, the left comma, would become disjunctions, and the right ones would become conjunctions. I'm not sure. We can do it in the case of our calculi, preserving everything, and then the role of identity and cut changes. So yeah, there is a pretty obvious connection. It's just that, look, I'm reducing proofs, so basically I've just told you why Ryan's talk was very important, in case you missed it. That was a joke.
Let's think Bogdan one more time. We're going to take a 15-minute break, and then we'll resume again.
Hello, test.
I don't know if it's good. Yeah. And your stuff is after.
Yeah, I mean,
Hello, hello, test. Hello. Hello, test. Hello. Hello.
حطيت على 5 وهذاك حطيت على هنا. Hello, test, 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 test. Test. Hello, 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 hello. Hello, hello. Hello, hello. Test, 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 test. Hello, 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 hello. تمام؟
I don't think Greg can do it.
Actually, one thought I had about the technical stuff is the normal form theory.
Hello, test. Hello, hello, hello. Test, test, test. Hello. Hello, hello, test. Hello.
It should be in sort of very broad terms.
Okay, I'm going to make sure that my things are running.
Sorry to interrupt. They want to interview you.
Who? Did they come here?
Sorry, I'm the next speaker. Okay, I want to just check that the system, my slides are up and running.
Yeah.
I won't fiddle with this because I'll do something terrible. Okay, so let's follow backwards. Does the water work?
Should be. It's a screen.
They don't reflect on these things. Okay, all good.
And sorry I couldn't take your question.
It's not a problem. I know time is tight.
Yeah.
And it wasn't a very profound question anyway.
No, I'm sure it is.
No. What's that for?
For the live stream. It is my honor to introduce our first keynote speaker of the symposium, a person who needs no introduction. Everyone in this room knows Graham. So let me introduce Graham Priest to talk about uber-consistent logics and dialectics.
Thank you, thank you. And first of all, let me say thank you to the people who are responsible for this conference. Rashid, of course, the faculty for all the support, and of course the people who provided the funding. So thank you. I think this is an historic occasion. This really is, as far as I know, the first conference on modern logic in the Arab world, and I hope it'll be the first of many. I think it's terrific the way that modern logic is becoming such an international thing with cooperation from people all over the world. So that's great, and I'm looking forward to the next couple of days to hear about what you guys are doing and other people. So, thank you. We're going to have fun. I was in Germany last week and I picked up a kind of sore throat, so I'm a bit croaky, but I hope you'll forgive my voice if it's not sort of normal. Okay, so what I want to speak about but logics where logic tells you that the logical truths are themselves contradictory. We've known about logics of this kind for a long time, at least, I guess, 30 years. But in the last 10 years or so, it's been recognized there's a very large class of these logics. And they have interesting structural properties and, I guess, raised philosophical issues. A lot of work has been done in Germany by the Group in Bochum. They don't really have a standard name yet. Heinrich calls them contradictory logics, so that's kind of boring. So I call them uber-consistent logics because it's
sexier, right? You can call them what you damn well like, I don't care. Okay, so uber-consistent logics tell you that logical truths are themselves inconsistent. And what concerns me today is the relevance of this for dialethism, the view that some contradictions are true. And you might think that, if an uber-consistent logic is correct, then dialethism follows immediately, because, as my hero puts it, if sheer logic is not conclusive, what is? Okay, so that's a quote from Quine, of course. So if logic tells you that the truths are consistent, well, then some truths are contradictory. Okay, it's not that straightforward, unfortunately. So what I want to do today is sort of explore the question of what we can learn about dialethism from uber-consistent logics. And as I say, it's not as straightforward as one might think. So here's where we're going. There's an introduction, you just had it. To say what I want to say, I'll give you some preliminaries to make sure we're all on the same page. And then when we've done that, I'll talk about three uber-consistent logics and talk about the relationship of those to dialethism and providing arguments for dialethism. And then I'll just say a few words to conclude. And I'm going to try and hold this down to 40 minutes so that it'll leave us at least 10 minutes for discussions. Okay, so, yeah. Okay, so preliminaries. Some definitions. So, a pure logic comprises at least a formal language L with a set of formulas F, a distinguished one-place connective, our friend the angle, and a relation. It's an inference, so that turnstile is the consequence relation. it can have as many premises as you like, and a single conclusion. I mean, you can generalize to multiple conclusion. Today, single conclusion is fine. Okay, now a pure logic is a pure mathematical structure. There's no sense in which it's right or wrong. It's just a bit of pure mathematics. Okay, so I'm going to require that the consequence relation satisfy the standard Tarski conditions so that it's reflexive, monotonic, and transitive. Transitivity is kind of interesting in its own right. I might come back and talk a little bit about that in a minute, but at least for the moment, I'm just going to assume that the consequence relation is transitive. Okay, so that's a pure logic. Now, a pure logic is just a piece of pure mathematics, and it can have many applications, and some of those have nothing to do with logic as traditionally understood. So, let me remind you that what's sometimes called Boolean logic in the computer science context is first order proposition logic, classical proposition logic. And in that, the formulas represent logic gates, okay, collections of electronic circuits. And the inference relation just says if current flows through all the gates on the left-hand side, it flows through the gates on the right-hand side. So this has nothing to do with logic as traditionally understood, but it's a perfectly legitimate application of logic, the mathematical structure, which you may have learnt if you studied Computer Science 100. So a pure logic has many applications, or can have many applications, but it has what you might call a canonical application. That's what sort of these things were invented for in the first place. And in the canonical application, we're dealing with inferences in natural language. So in a canonical application, the formulas of L represent statements of natural language. The angle represents negation, and the turnstile represents the consequence relation. So that will be the canonical application of a pure logic. And thus applied, a pure logic delivers a verdict on what inferences in natural language are valid and what are not. And as I don't think I need to tell you, different pure mathematical structures will deliver different verdicts. So classical logic will tell you that double negation elimination is valid. Intrinsic logic will tell you that it is not. So different logics provide theories, in effect, of which inferences are valid. Remember that no one, even mathematicians, do not reason in formal languages. They reason in the vernacular. Maybe the vernacular augmented with certain technical terms, but no one reasons in a formal language. Okay, so a pure logic, when given its canonical application, gives you a theory of which inferences are valid and which are not. And if their machinery is sufficiently rich, it's got some model theory or some proof theory, it will tell you why as well, which is kind of much more interesting, but much more contentious. Okay, so some more different definitions to make sure we're on the same page. A theory under a consequence relation is a subset of the formulas closed under the consequence relation. There's the definition. If A follows some sigma, then it's already sigma. Theory is a logician's term of art, but it's a standard one, and it has a function. We can come back to it later, but that's the standard definition of a theory. A theory is inconsistent if it contains A and not A. So this is a bit different from the notion of inconsistency in the second talk, but it's the way I'm going to use the term. It's inconsistent if it contains A and not A for some A, and it's trivial if it's everything. In other words, the theory contains every formula. Okay, so explosion, which we've met already this morning, is the inference that for all A and B, if A and not A, then B. Okay, those are all standard definitions, right? Another standard definition, the turnstile is paraconsistent if first definition, explosion is not valid. That's the kind of standard definition. It became sort of standard, I guess, in the early 80s. Then there's no word for dialethism at that time, and people were using paraconsistency to mean both what we now call paraconsistency and also dialethism. It was very confusing, but the standard definition of paraconsistency now is that it's a logic, an inference relation where explosion is not valid. Now there's another possible definition. There are inconsistent but non-trivial theories under turnstile. Those two definitions are equivalent given the three structural rules that I gave you. They are not equivalent if you get rid of transitivity. And when the definition of paraconsistency became standardized, non-transitive logics were known, but they were not terribly significant. That, of course, has changed now, as you know, we've heard already this morning, as people like Ripley and Cabreros and company have argued that they provide the correct solution to the paradox of self-reference. Now, I think you should build transitivity into the definition of a consequence relation for reasons I'm not going to go into now. We can talk about it in the discussion if you want to, but given that these two definitions are equivalent, and certainly the first definition is kind of simpler. So I'm going to stick with that. Okay. Now, so that's paraconsistency. Dialethism is the view that there are some dialethias. Okay, what's a dialethia? Well, since I coined the word with my sadly deceased old friend Richard Sylvan, let me give you the quote. The notion of a true contradiction is at the heart of this book. Awkward as neologisms are, it will therefore be convenient to have a word for it. I will use dialethia. So to avoid any confusion, let me say right at the start that a dialethia is any true statement with the form alpha, and it's not the case at alpha. And dialethism is therefore the view that there are dialethias. Okay. So this is not a view about a consequence relation. It's a view about what things are true. Of course, if you are a dialetheist and you don't want to believe that everything is true, then you better subscribe to a paraconsistent logic. But most paraconsistent logicians have not been dialetheists. But for better or for worse, that is the definition of a dialethia. And people often say to me, yeah, what do you mean by truth? And I say, anything you damn well like. Okay, you tell me your favorite theory of truth, that's what I mean by dialethism, all right? So there's no thought that I'm dealing with a realist theory of truth or a pragmatist theory of truth or a deflationary theory of truth. I don't care. All I care about is the truth of dialethism in whatever sense you like. All right, so now let's come back to the connection between dialethism and uber consistency. A paraconsistent turnstile allows for inconsistent but non-trivial theories. We know that. But it doesn't commit you to the truth of any such theory. And many logicians have been interested in inconsistent theories, which they didn't take to be true. Most of the Brazilian paraconsistent logicians aren't dialetheists, but no, Newton da Costa was very interested in inconsistent theories. However, if such a theory is true, so is dialethism. Now, the set of logical truths is a theory. It's closed under logical consequence. So if an uber-consistent logic is correct, we would seem to have dialethism, because it's a true theory which is inconsistent. Remember, an uber-consistent logic is one such that the set of logical truths is itself inconsistent. So if the logic is correct, the logical truths are true, of course, and they're inconsistent, so you've got an inconsistent theory, which is true, so dialethism follows. Well, at least that's how it might seem. But it's a bit more complicated than that. So that's the preliminary stuff. That's just to tell you where I'm coming from with the definitions and so on. Now let's talk about some uber-consistent theories and have a look at their more detailed connection with dialethism. Okay, there are now many well-known uber-consistent pure logics. Heinrich Funzing has a very nice paper which he categorizes at least 7 or 8 very different uber-consistent logics. And the theories of validity delivered by many of them are not particularly plausible, it must be said. So one of them is this logic called abelian logic. You don't need to know the details. It's called abelian logic because the logical structure of the fusion operator is an abelian group. You don't need to know what that means. Just take my word that it makes sense. Okay, now the characteristic axiom of abelian logic is this guy. Now, that's actually not very plausible because just take B, take B to be if A then B. Then an instance of that is this guy. Now, the left-hand side is the contraction principle. And some people like it, some people don't. I don't, but there you go. But, you know, even if the contraction principle is true, A doesn't seem to follow. I mean, some people like the contraction principle as true for every A and B. So certainly if you like that, A doesn't seem to follow. So there are many pure logics, of which abelian logic is one, such that when you give them the canonical application, the theory of consequence you get is not terribly plausible. So I'm going to set those aside, and I'm going to look at 3 theories for which the canonical application is a bit more plausible. So, first of all, a paradoxical constant. Okay, so I'm going to talk about the logic LP, which we've met already this morning. It will be familiar to many of you. For those of you to whom it's not familiar, let me just tell you the idiot's guide to LP. It can be formulated in a number of different ways, but a very standard way is to formulate it as a 3-valued logic with the values T, B, and F. So true and true only, both true and false, false and false only. Okay. And the crucial thing from present purposes is that negation has that matrix. And this is a many-valued logic. So in many-valued logic, you'll want to know which values are designated. And a valid inference is one that preserves designated values. And the little asterisks tell you what the designated values are. So intuitively, validity is about truth preservation. And in LP, you've got 2 species of truth, namely true and true only and true and false. So a valid inference is one that preserves both those values. So if the premises are either T or B, so is conclusion. Okay, so that's LP. Now, LP is paraconsistent. That's not too difficult to see because take an A such that it has the value B, then A and not A both have the value B, and so are both true, and false only, but they're true. And take a conclusion, which is false, F. Then that's a counterexample to explosion. So LP is a paraconsistent logic, but the logical truths of LP are the same as those of classical logic. Now that's kind of surprising if you've never met this before. We often used to identify logic with a set of logical truths. You can't do that. It's not even clear that you can identify it with this consequence relation, thanks to the Argentinians amongst us. Okay. But anyway, LP has the logical truths of classical logic, so it's paraconsistent, but it's not uber-consistent. Because classical logic is not uber-consistent, obviously, right. Okay, now, suppose you add 3 logical constants to the language T, B, and F, and I boldfaced them because each of these just refers to the corresponding logical value. Okay. Adding logical constants for the semantic values is the par for the course in logical technology. Often you will see classical logic given to you with constants T and F. In relevant logic, you'll see big T and big F, little t, little f, and so on. So adding logical constants for the relevant values is pretty standard. And if you add the constant B to the language, then of course this is going to be a logical truth. So adding the logical constant to the language has turned it into an uber consistent logic, because there's a logical truth that's contradictory. All right, so you might think, well, so look, the case that LP delivers a credible theory of validity has been argued at length by me and other people. I'm not going to rehearse that. And it can hardly be an objection to adding constants for the logical values to the language. So that move doesn't seem to be terribly problematic. But of course, if you do that, then what we've just seen is that you have got an uber consistent logic. So if LP is the right mathematical structure for our inferences, you've got dilethism. Okay, so LP augmented by B would seem to provide an argument for dilethism. Okay, it's not that simple though, because, objection, since the argument presupposes the correctness of LP, the logic adds nothing to the case of dilethism. So you've got to suppose there's a logic, there's a value B in the first place, and you might think, well, that kind of presupposes dilethism. And there's something right about that objection, but something wrong as well. So let me tell you what I think is the case. Let's call an interpretation of veridical if it's one where the truths in the interpretation are true simpliciter. So an interpretation is just an assignment of truth values to formulas, and what's true in the interpretation may not be true simpliciter. So in classical logic, I can give you a sentence which is true, which might mean Kuwait City is in China, or that something is red all over and green all over. These are not veridical interpretations. But with a bit of luck, some of our interpretations are veridical because we're really interested in truth preservation. So let's call an interpretation veridical if what's true in the interpretation really is true. Oh, interesting. Just play amongst yourselves for 5 minutes. Yeah, okay. Okay. Uh-huh. Okay, well that helps. Yeah. But, I like that. But, that's all, folks. But nothing. Okay, here it comes. There's nothing that requires a veridical interpretation to verify contradictions. But with the constant B, obviously there is, because every interpretation verifies contradictions. So a fortiori, every veridical interpretation, assuming there to be one, verifies contradictions. Okay, so the addition of the constant B doesn't actually give you a new case for dilethism, but what it will do is take you from the mere possibility of taking things to be contradictory. In other words, in some sense, the existence of interpretations which verify a contradiction to their actuality. So I don't think that adding B gives you a new argument for dialetheism, but what it does do is sort of bulk up an old argument and take you from the possibility of a true contradiction to its actuality. Okay, so that's the first of 3 examples. Let's move on to the second example, which is second order LP. So I'm assuming that you all know what second order classical logic is. Second order LP is exactly the same, except that you're using LP. So in second order classical logic, you take your second order quantifiers to range over, well, maybe properties or sets or something else, but sort of higher level things than the first order domain. And in second order LP, it's exactly the same, except that the second order entities are going to be pairs, because now we've divided truths and falsities, you've got to, and treat truth and falsity separately, you've got to divide extensions and anti-extensions of predicates and treat those even-handedly. So first order quantifiers range over a first order domain, D1. Second order quantifiers range over a domain, D2. And members of the second order domain are extension, anti-extension pairs. So they're of the form EA, where E union A sum up to D1. Okay. If you drop that, you get first degree entanglement. But this is LP. Okay, so that's second order LP. And if the second order domain comprises all pairs of that form, given the domain, the first order domain, it's uber consistent. And we've known that for a long time. This is probably one of the first uber consistent logics that was in the literature. So all interpretations contain this thing, right? That's just excluding middle. But if the second order domain contains all pairs, it will contain this thing as well, because it contains the second order object, where both the extension and the extension are the first order domain. So in fact, everything is going to have at least one contradictory property. Okay, if you just fiddle around with that second formula, you get that, and that's the negation of that. Okay, so it's uber consistent. And as I say, the uber consistency of this logic has been known for a long time. Okay, so far so good. Now, the question becomes, if you're thinking of the canonical interpretation of this bit of mathematical machinery, do you want your second order logic to be full, in other words, to contain all extension, anti-extension pairs? And that's going to depend on what you take the second order objects to be. If they're just sets, well, you can do anything you damn well like. But if you want them to represent properties, for example, you might want to be more restrictive, since some sets don't look like serious properties. Okay, so most of you will know that in second order logic, there's a comprehension principle, which is this guy. So A contains, mustn't contain the big X. So that tells you that every condition defines a second order object. Okay, and we know that there are models of comprehension which do not contain everything that's possible in the second order domain. So these are called Henkin models. And we know, because of the work of people like Henkin, that there are models of classical second order logic which verify comprehension. So they're pretty strong, but they don't contain all second order objects. Now, classical interpretations are special cases of LP interpretations. They're just ones where everything is consistent. So if there are classical Henkin models, there are LP Henkin models. And LP Henkin models just have classical behavior at the second order level. So if you're prepared to restrict your second-order denizens, members of the second-order domain, so that they're not all there, then it may not be uber consistent. It just depends what you've got in the second-order domain. And you might say, well, if you're going to get an argument for dialethism out of this, then you need an argument that there's at least one inconsistent thing in the second-order domain. So one member of the second-order domain where the extension and anti-extension overlap. And you might think, well, that's pretty much tantamount to an argument for dialethism. So maybe you don't get a new case for dialethism. So the case for dialethism turns on whether you expect your second-order domain to contain every possibility, every extension, anti-extension pair, or not. Okay, so that's where that argument goes. All right, let's talk about connectivism. What time did I start, Richard?
About 11.
Okay.
So you get there.
Okay, good. So connectivist logic, some of you will have heard of connectivism, some of you may not have done because it is, at least until recently, a fairly esoteric kind of logic, although it plays an enormously influential role in the history of Western logic. All right, so there are these principles which commonly get called Aristotle and Boethius. Actually, they can be formulated in a number of different ways, but this will do for our purposes. And as you can tell by the name, people think you can find an endorsement of this principle in Aristotle and Boethius. Certainly, and I think that's right, okay. I think it's much clearer in Boethius and Aristotle, but never mind. Certainly, these principles were endorsed in medieval logic until about the 11th century. And then they fell out of fashion for reasons we can talk about if you want to. Although you still find people appealing to them in Europe in the 17th century, 18th century. But they've fallen out of favour now. Look, Boethius entails Aristotle if you've got identity, if A then A. So I'm just going to talk about Boethius. Now, logics that contain Aristotle and Boethius are called connexive logics. And as I say, there are at least orthodox in logic until about the 11th century. Okay, now, connexive logics are not necessarily uber consistent. We know that there are plenty of consistent, uber consistent logics. However, suppose your logic contains the standard rules for conjunction elimination as well as the connexive principles. Then, okay, so you've got these two things. So those are just instances of the conjunction principles. And because of, where are we? Okay, from this one and Boethius, you've got this. So these two obviously contradict each other. Okay, so a connexive logic is not necessarily uber consistent, but if you've got the conjunction principles as well, it is. And actually, this is one of the reasons why connexive principles fell out of favour in the 11th century, when something like the modern thought about conjunction started to become more orthodox. Okay, so that's an uber consistent logic. Now, okay, let's assume that the conjunction principles are not terribly contentious, maybe. The question then becomes, what do you want to make of the connexive principles themselves? And sort of, they have a certain intuitive plausibility, right? Yeah. If I go to the movies, will you come with me? No. If you go to the movies, I will not come with you. Okay? That's kind of plausible, right? But sort of plausibility will get you so far, but not very far. I mean, to see whether these are plausible conditions, plausible principles of conditionality, you need to know something about the semantics of the conditional. Surprise, surprise. And it must be said that if you look at the semantics of most connective logics, they're pretty ugly. All right? They're a bit like abelian logic. They're not very plausible. However, there's one set of falsity conditions which are very natural and which give you the connective principles. And these are actually are made well known by Heinrich Wunzing himself, although they were produced by a logician called Cooper way back in the 70s, and the paper was ignored. Okay, so the Wunzing falsity conditions. So we're playing a game where we treat truth and falsity even-handedly. Never mind the truth conditions of conditionals for the moment. What about the falsity conditions? And the Wunzing falsity conditions is that if A then B is false, if and only if A then not B is true. As I said, if I go to the movies, do you come with me? No. If you go to the movies, I won't come with you. Okay, now suppose that, let's prove Boethius. Suppose that if A then B, then by double negation, if A then not B, so if A then not B is false, that's by the Wunzing conditions, and that is this. So that we started assuming that if A then B, and we've inferred this, that's Boethius. So if you endorse the Wunzing falsity conditions for a conditional, then you've got an uber-consistent logic. And I think in some ways this is the most interesting example of an uber-consistent logic. But the fact that you can do this doesn't mean that it's the right thing to do, okay? So why might you think this is the right thing to do? Well, first of all, notice that it needs us to give truth and falsity conditions independently. You don't do that in classical logic, because if you know the truth conditions, you know the falsity conditions and vice versa. But in nearly all non-classical logics, truth and falsity are separate, so you've got to handle them independently. Okay, so there's an issue here, but let me pass that over. It's at least a very familiar issue. What we need to know now is whether or not the Wunzing falsity conditions are very plausible. And as I said, they have a certain superficial plausibility. So, what are the falsity conditions of a conditional? A small question, okay. Look, think about the truth conditions of a conditional for a moment. In the history of Western logic, what is the most contentious connective? It's not negation, it's the conditional. I mean, we've had multiple theories of the conditional since at least the Stoics. So, the trouble with conditionals is that there seem to be a number of plausible kind of criteria, and they don't all fit together. So it's hardly surprising that we've had many theories of the conditional in the last 2,500 years. And I think, you know, consensus comes and goes again sometimes. But there's a real problem about the truth conditions of conditionals. And it's due to the fact that we seem to have so many competing desiderata for the truth conditionals that they don't all fit together properly. That's the truth conditions. But what concerns us are the falsity conditions. Now, the falsity conditions are difficult as well, but for the opposite reason. Namely, for the truth conditions of a conditional, we seem to have too many considerations which don't fit together. For the falsity conditions, we don't seem to have many considerations at all. I mean, if you think about it, negated conditionals play virtually very, very little role in our reasoning. They play some, but nowhere near as many as true conditionals. So, determining the falsity conditions of a conditional is kind of hard because we just don't have so much data. There is a bit, we can talk about that if you want, but that's where the debate goes. Okay, so if connective logic gives you an argument for dialetheism, that's where the rubber hits the road, I think. Okay, so conclusion. All right. So we've looked at 3 examples of uber-consistent logics, and I've been concerned with the question of whether they give you a case or a new case for dialetheism. What I can sort of conclude is that what we've seen is that the relevance of uber-consistent logics for dialetheism raises a number of sensitive issues, and I've been over them very fast. But if you were to sort of just summarize the general gist of what I've been saying, so on balance, such logics would seem to strengthen the case for dialetheism. I'm not claiming that they prove dialetheism or anything like that, but I think some of the considerations that I've been considering at least sort of strengthen the cases for dialetheism. So, as I said at the beginning, this is a very new class of logics, and there are lots of things to be thought through. There are still lots of technical problems about uber-consistent logics to which we don't know the answer. But set those aside, there are a number we do know the answer to, but their philosophical significance about dialetheism and other things, particularly the conditional, there's a lot of work to be done in thinking about the ramifications of this new class of logics. So, you know, modern logic's great. We've discovered lots of new class of logics, and every time we discover a new class of logics, they raise all kinds of cool philosophical issues. Well, this is just one where we're starting to play the game. All right, so thank you. I hope that says contradiction in Arabic.
It is.
And this, I'm told, is a transliteration of dialetheism.
Thanks, Graham. I had a question about the first example involving the constants for the truth values. In your argument for sort of introducing this, you sort of, well, this is standard logical practice to be able to introduce these constants. But it's not always clear exactly how these should be interpreted. I mean, technically, of course, but like, I've seen, for instance, in text books, people will say, well, truth is always true. So, but that's a category, right? So it's not clear exactly what propositions or what these logical constants are expressing, right? People will often refer to the top and the bottom as the true and the false, but that seems problematic because it's a category error to say the true is true. And so one option is to say, well, pick your favorite, true, 1 = 1 or 0 = 1, but obviously that's not available as an argument without begging the question. So I was wondering what you were thinking in terms of actually interpreting these things as expressing propositions.
Good. Look, to be honest, I wasn't thinking about that. When I said that it was standard, well, I was just talking about the pure mathematics of it. So in any many-valued logic, you open any textbook on many-valued logic, you'll see people say, well, we can add logical constants for the values, and that simplifies the axiomatization. That's what I was thinking of. Now, you've raised another point. How would you interpret those constants in natural language? And this is really interesting. This is going to depend on various philosophical issues. Look, if you're a dialetheist, there's no problem about B. Choose your favorite dialethia. The problem is actually with the other two, because if you're, what you want T to be is something like true and true only. Now, if you're not a dialetheist about the paradox self-reference, that's fine. It's just that, right? So choose any sentence that's true and true only, like 2 + 2 = 4. Then T is that. Now, if you're a dialetheist about the paradox self-reference, then true and true only is going to behave inconsistently itself. So you can't quite do that, because I can't say, well, just choose any sentence which is true and true only, because that might actually end up having the value B. So I can't give you a kind of categorical definition. We have to go back to giving you an example, such as 2 + 2 = 4, or for F, 2 + 2 = 17. So that's an interesting question, but I think that's where that issue goes.
Does it work? Yeah. So I think it's a friendly suggestion about the second order LP case. There was a problem that the way you did it, that we get a contradiction only if we have this very abundant conception of property.
Yeah, it doesn't have to be completely abundant, but at least there's got to be something in the second order domain where extension and intersection overlap. Yep.
I was wondering, maybe the worry is less pressing if you focus on because you were focusing about properties of objects, but once you go second order, you also have the extreme case of properties that take no object, that is proposition, like zero place properties. And then you don't get, I don't think the issue about abundance is very pressing, because you only get very few possibilities of propositions that have the values as extension and anti-extension. So it might give you a slightly tighter argument for.
Good.
Then you get there is some P such a P and not P, and then similar to how you reason, then you also get a contradiction that not for all P other P or not P. So you might tighten a bit the argument of that section.
Yeah. No, that's right, thank you. And in fact, what you're gesturing at is a connection between my first case and my second case, because if you've got, I was assuming that the constant B is not in the language, but if it is, you've got a zero-adic second-order object. So that will give you an inconsistent thing in the second-order domain. And there might be other things that have this structure, nature. The question still remains why you should suppose there to be something like that. Now, if you get it with the constant B, well, we've been discussing that issue. If you give some other argument, it'd be kind of interesting to know what one might have in mind here. But you're right, that you don't need full second order domain. You just need a little bit of it that's inconsistent.
In the case of proposition, right, it's not that you have worried that, I only have a true proposition, because you also have the false proposition in a classical case. So once you go to LP, you have 3 possible things.
Yeah.
You should go for all 3 of them.
Yeah, yeah. So we're back to sort of the first case. I mean, the constant little bold-faced B. But thank you.
Let's thank Graham one more time.
That's yours. That's one. Perfect.
Thank you. Need to wear these two.
glad to introduce Camillo Fiore with the title LP, K3, FDE, and their generalized classical collapse.
Okay, thanks. This is a joint work with Lucas Rosenblatt, also from Buenos Aires. And it is about what is known as classical recapture, in case it rings a bell. So let's start by supposing that you endorse some subclassical logic L. Very roughly, a classical recapture result for L tells you that if a domain of discourse satisfies certain safety conditions, then all of the principles of classical logic are sound within this particular domain. Arguably, such a result is quite useful to you, and in particular, it allows you to answer one of the most prominent objections against the use of subclassical logics, namely the objection that they are deductively too weak. So the idea is to claim that many key domains of discourse, such as, for instance, arithmetic, satisfy the safety conditions specified by the recapture result, and hence the objection does not apply to these domains. Now, J.C. Bill, in an article entitled LPK3 FDE and their classical collapse, provided recapture results for the multiple conclusion variants of logics LP, K3, and FDE. So writing CL for the multiple conclusion version of classical logic, informally, each of the results by Bill tells you that if a given inference is valid in classical logic, then there is another inference with some additional premises and or conclusions that is valid in the target non-classical system. However, the philosophical relevance of Bill's results have been questioned. The problem is that the results by Bill only allow us to recapture classical non-logical theories if we understand a theory as a set of statements or sentences. And many actual theories cannot be understood in this way. Apart from sentences, they also comprise inferences. So the problem is that Bill's results give us with no guidance for recapture in the case of such theories. So what I basically do in this talk is to present generalizations of Bill's results which solve this problem. So you see three parts there. We will only address the first and the second one, and we will not have time for the third one. So we work with a typical first-order language with primitive constants, negation, disjunction, and the existential. We use A, B, C for formulas and gamma, delta, sigma for sets. And we will define our systems using the classical, the Strong-Clini, and the Belknap-Dunn models of this language, with which you probably all know pretty well. So I will go through the next couple of slides rather quickly. We define an interpretation of the language as a pair having a domain and an interpretation function, and in particular, for each n-ary predicate, the interpretation function assigns a function from n tuples of the domain to the relevant set of values. So for instance, in Strong-Clini, the values are 1, 1.5, and 0, and in FDE, we have 1, b, n, and 0. A model is just a pair having an interpretation and a variable assignment nu here. And, well, the denotation of terms is defined as usual, and the notion of X variant of a model is also defined as usual, namely two models are x variants if they differ at most in what they assigned to x. And we also have the notion of a nu variant. So two models are nu variants if they differ at most in their variable assignments. All these things serve to define the value of a formula in a model, which is defined also as standardly done. Here we have these two orders on the sets of values of strong Kleene and FDE. And we define an inference as a pair of sets of possibly open formulas. And we have the definitions of satisfaction of an inference. Since inferences can contain open formulas, we have to take care of these formulas in our definition of inference satisfaction. That's why we have to quantify over nu variants. So for instance, in classical logic, a classical model CL satisfies an inference just in case for every nu variant of this model, either some premise is false or some conclusion is true. Basically, K3 satisfaction is preservation of value 1, LP satisfaction is preservation of value 1 or 0.5, and FDE satisfaction is preservation of value 1 or B, always quantifying over nu variants. And an inference is valid in a logic L, written like that, just in case every relevant model satisfies it. A last bit of definitions. So suppose we have an atomic formula P. I will not pronounce the terms out loud. So the inconsistency claim for P is just the existential closure of the claim that P is inconsistent. And the completeness claim for P is just the universal closure of the claim that P satisfies excluded middle. We use alpha of a set gamma of formulas for the set of all the atomic subformulas of formulas in gamma. And then we have the inconsistency set, iota of gamma, and it is just the set of all the inconsistency claims of the atomic subformulas of formulas in gamma. And similarly, we have the completeness set of gamma, which has all the corresponding completeness claims. Okay, so these are the results by Bill, basically. So gamma entails delta in classical logic, just in case gamma together with the completeness set of delta entails delta in K3. Gamma entails delta in classical logic, just in case gamma entails delta together with the inconsistency set of gamma in LP. And to have recapture in FDE, we have to add all the things we needed to add in the cases of K3 and LP. So now we go to the problem of the problem for the actual application of this kind of result and our solution. So we will focus mostly on the example of K3. So Bill's result for this logic can be informally stated as follows. If premises gamma entail alternatives delta in classical logic, then the same premises, together with the additional assumption that all predicates in delta satisfy excluded middle, also entail alternatives delta in K3. So here we can think of the things in gamma as the axioms of a theory. And in turn, we can think of the things in gamma union kappa of delta as the axioms of a theory that recaptures in K3 the classical consequence delta of gamma. So in short, Bill's recipe for recapturing K3 is to recapture the classical consequences of your axioms. You should assume that those consequences satisfy excluded middle. Okay? Now, suppose that you are studying some domain of discourse T, and you think that this domain is consistent but paracomplete. So you employ logic K3. And let P be any atomic Guppy statement about this domain. So a statement that does not satisfy excluded middle. You want, of course, to restrict the models of your theory to those where excluded middle fails for this atomic sentence. However, there is no single collection of claims that you could add to your theory to express this. For instance, if you added the negation of excluded middle for P, since this is unsatisfiable in K3, you would be left without models at all, and hence you would be left with a trivial theory. So the solution is to add an inference, namely P or not P there for absurdity, here represented by the empty set. And this inference exerts on your models exactly the effect you are looking for, right? However, Bill's results now give us no guidance for recapture. So to see why, consider that the set of the classical models that CL satisfy this theory T, having this inference we mentioned, this set of models is empty, and hence it satisfies every inference. In particular, it validates the inference going from the empty set to Q, where Q is any other atomic statement. But the set of strong Kleene models of the following theory, which is T with union with an inference going from the empty set to the completeness of Q, this set of models is non-empty, and it does not validate the inference from the empty set to Q. And moreover, this theory is precisely the theory that we should expect to recapture the classical consequences of the first theory if Bill's recipe would work in this context. Because in this inference we added, we are expressing excluded middle for the consequence that we could classically extract. So in this context, Bill's strategy does not work anymore. So the solution is basically to generalize Bill's results to the level of meta-inferences. Intuitively, a meta-inference is just an inference whose premises and conclusions are themselves inferences. And each of our new results will say that if a certain meta-inference is valid in classical logic, then there is another meta-inference with some additional premises that is valid in the target non-classical system. More formally, we define a meta-inference as a pair having a set of inferences and a single inference, and we denote it also with this with a Lewis stroke. A model of a logic L, L satisfies a meta-inference just in case if it L satisfies all the premises, then it L satisfies the conclusion, and a meta-inference is valid just in case every relevant model L satisfies it. This is the so-called local notion of validity. We can discuss later why the global one does not work in this context. So the first theorem is meta-recapture for K3. So basically a meta-inference star having as premises all the gamma I delta i's and as conclusion sigma pi. This meta-inference is valid in classical logic just in case the following meta-inference is valid in K3. So we have all the premises that we had before, the same conclusion, but we added as premises basically excluded middle for all the things that are either in pi or in some of the gamma i's. So basically we add excluded middle for all the conclusions of the conclusion and all the premises of the premises. Dually for LP, a meta-inference is valid in classical logic just in case the following meta-inference is valid in LP. So we, in this case, added explosion for all the things that are either in sigma or in some of the deltas. So we are adding excluded middle for all the premises of the conclusion and all the conclusions of the premises of the meta-inferences, And in the case of FDE, we again add all the things we needed before for recapture. So if we look informally at the result for K3, we say that if the premises gamma I delta I entail sigma pi in classical logic, then the same premises, together with the additional assumption that excluded middle holds for all the predicates in the gamma i's and in pi, entail sigma in K3. So here we can think of the premises gamma I delta I as the axioms of a theory, and they, together with the corresponding inferences from the empty sets to a completeness claim, form the axioms of a new theory that recaptures in K3 the classical consequence sigma pi of the gamma I delta i's. So our recapture result does account for theories that contains inferences besides formulas. So for instance, given the theory T that we had before, whose only inference is P or not P, therefore absurdity, by our result, we know that a theory that recaptures the classical consequence empty set therefore Q of T is the theory having T and these two inferences going from the empty set to the completeness of P and from the empty set to the completeness of Q. So in this talk, I have explained the shortcomings of Bill's results, mainly with toy examples, but the results are relevant for actual cases in the philosophical literature. Indeed, the objection that we are addressing comes from an article by Nicolai called The Dream of Recapture, and Nicolai uses an example from formal theories of truth. So the results we have seen also apply to the case considered by Nicolai and hence also answer his objection. Indeed, Lucas Rosenblatt and I, in another work, already provided variations of Bill's result that are meant to answer Nicolai's objection, but the current results are more satisfactory in a number of ways. Okay, so I will say just a few words about what is this last part about. Basically, one could also come up with theories that not only contain formulas and inferences, but also meta-inferences, and also meta-meta-inferences, and so on and so forth. So, for instance, in theories of truth, maybe you heard about theory Fs, which has the meta-inference going from A being a theorem to A being true, or the truth of A being a theorem. This is a typical example of a meta-inference that may be part of a theory. So the result I presented does not work for these other theories very much in this, like the original results by Bill didn't work for theories that contain inferences. That's why we have a general result which applies to any meta-inferential level and which has the results I presented here as a special case. And indeed, the general result we have establishes an interesting connection between recapture for LP and K3 and the so-called ST hierarchy that has been studied by some people. Basically, the K3 theorist has to assume excluded middle exactly where the ST hierarchy is tolerant. And on the other hand, the LP theorist has to assume explosion exactly where the ST hierarchy is strict. So, all in all, to have recapture, they always have to assume classicality exactly where the ST hierarchy is different from their own logic. But we can discuss more this point later. So, we skip all this.
I get slightly confused about the motivating example, because the idea is we want to show that in K3, if we have a context where everything is complete, then we can get all of classical logic that's the idea of recapture, if I understand it. But then the example you give is a specific one where we know for a fact, or we take that as part of the theory, that this sentence P is not either true or false.
Yes, but sorry, I didn't get the question.
So the idea behind these recapture results, the motivation behind them, if I understand correctly, is that you want to show that if we're working in a specific topic like arithmetic,
yep.
where we know that things are complete, then even the K3 proponent can appeal to all of classical logic.
Yep.
But then the specific example you gave about theories which have inferences as part of them is an example where apparently we know that there's some P which is neither true nor false. We know for a fact that we're working in a context where we don't have completeness.
Yes.
But then I don't understand why you would want to recapture classical logic in such a context, because that seems like a context where classical logic shouldn't apply if you're a K3 proponent.
Yes, you're right. I think this is only a problem of my example because I wanted to use the example for two different things. But actually, in the case by Nikolai and in other cases where you take a classical theory, which of course doesn't have a sequence of this form, you need the recapture results to recapture those theories. So I only used this example because I also used the example to show that you need to add inferences, but there are other theories where you have inferences as part of them.
Right, okay, I understand, thank you.
Thank you.
It's about the more or less the same thing. So I understand it's very important to be able to recapture the inferences, but the motivating example you gave with this P that we know might fail to have excluded middle. I find it a bit strong to model that idea by adding the inference that then P or not P is inconsistent, because we might know that it fails excluded middle for absolutely contingent reason, like take the contingent version of semantic paradox, that it's another normal understanding of inconsistencies, not that it's inconsistent to say P or not P. Just as a matter of fact, we cannot accept excluded middle because as a matter of fact, the relevant sentence happens to be the first sentence on the board, and all these standard examples that you have for contingent paradox. So there might be cases where we want not to accept the excluded middle for P, but we don't want to accept the logical claim that P or not P is inconsistent.
Yes, so if the sequence P or not P, therefore absurdity, is part of your theory, it is not a logical sequence. It is not a logical claim. It's just the claim that, as a matter of fact, P or not P does not hold.
So you don't interpret a sequence as expressing logical consequence?
No. So the Lewis stroke is not necessarily logical. So if you have a logical theory, then yes, that stroke is logical consequence. But if your theory has inferences, then those inferences, like the stroke in those inferences, does not stand for logical consequence anymore.
Just for true simplicity.
Preservation of truth in the veridical model, to speak in Graham's word.
Yeah, I'm a bit puzzled about what's going on for reasons that have already been canvassed. Look, I mean, the essence of the Beer recapture is that if you've got a K3, a theory based on the logic K3, you can get classical reasoning if you add every instance of excluded middle. Now that's a schema, okay? And it's a simple, combinatorial proof theoretic argument that then any classically valid inference transforms into a K3 inference with excluded middle and vice versa. So you've got classical recapture. And we haven't had to talk about inferences or meta-inferences at all. You just add a whole bunch of formulas, excluded middle.
I don't get the question or point, sorry.
Look, the Beale recapture just says, if you've got a K3 theory and you want to be able to reason classically, you just add every instance of excluded middle. That'll do it for you.
Yes, but the point is that your assumptions, your theoretical commitments are not always only formulas. So formulas are the kind of thing that can entail other things in the recapture by Beale. If your theoretical commitments are to be modeled by inferences, then Beale's result doesn't tell you anything. So Beale's result doesn't tell you if certain inference follows from others in classical logic, how to recapture that meta-inference in K3. And the point is that sometimes your theories are understood as sets of inferences. So the typical example is a theory of truth. If you compare, if you take a number of truth theoretic sequence and you take a theory with those sequence based on classical logic and on K3. So the difference here is that K3 can be transparent, like the theory over K3 can be transparent, but the theory over classical logic cannot. But of course, the theory over K3 cannot have all the T be conditionals, but all the T be sequence, so to speak. So okay. the K3 theory must have inferences, for instance.
Well, I wonder. I mean, I think JC is working in the context of an axiom system rather than sequent calculus.
So this is not so much about the work of Beale, perhaps, but about how the truth theoretic literature wants to apply this result. And the argument by Nicolai is that when you try to apply Beale's result to actual non-classical theories of truth, it is not useful. So to make it useful, you have to see at what follows, what inferences follow from what inferences.
Okay. Yeah, that appealing to the application in the context of theory of truth makes your point clearer. But I mean, notice that the Beale strategy is appealed to all the time in intuitionistic reasoning, because the intuitionists would always say that you can reason classically about a decidable situation just by adding excluded middle. So these considerations, if they're right, are going to apply to a lot of discussion in intuitionistic logic as well.
Thank you.
Let's thank Camilo one more time. I have one more talk before lunch. This talk is going to be online. Murtaza, are you there?
Yes, I'm there.
Could you try sharing your screen?
Okay, I sent if it is possible. Let me check. I'm not allowed yet. Sharing is not turned on. It is written here. I sent you the file.
Okay, could you try again sharing the screen?
Okay, let's try it again. It's better now. Share screen.
Perfect.
Okay. Can you have both slides and my sound?
Yeah.
Okay. Okay. Let me. Okay. Hi everyone. Thank you for being here today. I'm going to talk about two related issues in the philosophy of logic. Despite I'm logician, but I'm interested in foundations of logic, and these two problems I think that are most important in this case: the adoption problem and the rule following paradox. Single page. I also thank the organizers of the conference, especially Mr. Rochelle, for providing us such a wonderful opportunity to discuss logic and its philosophy. In this talk, I'm going to emphasize the interrelation of that two concepts, that two issues: the adoption problem and the rule following paradox. What is the adoption problem? This problem arises when we consider whether it's possible to explicitly adopt a basic logical rule and in doing so introduce inferential practices that follow it. The central claim here is that one cannot simply adopt a logical rule in isolation. To completely follow such a rule, one must already be an implicit practitioner of it. For example, if one does not already have a sense of modus ponens or universal instantiation, one cannot simply adopt them as an assumption and use them accordingly. This is the problem that raised by Saul Kripke. In an old talk but recently published paper, he emphasizes this point. You can't undermine intuitive reasoning in the case of logic and try to get everything on a much more rigorous basis. One has to just think not in terms of some formal set of postulates, but intuitively. That is, one has to reason. One can't just adopt a formal system independently of any reasoning about it, because if one tried to do so, one wouldn't understand the directions for setting up the system itself. Let me explain more about the adoption problem. Logical rules cannot be adopted in a vacuum. They rely on a pre-existing intuitive grasp of reasoning. Without this implicit understanding, the very act of adopting a formal system becomes impossible. The problem has been summarized by Berman as follows. The AP problem, a formal statement of this problem, as summarized by Berman in a paper published exactly in that paper written by Kripke in the journal Mind. AP, what is AP? Certain basic logical principles cannot be adopted, because if a subject already infers in accordance with them, no adoption is needed. And if the subject does not infer in accordance with them, no adoption is possible. This problem elaborated in several papers, especially by Berman himself. Again, more specifically, in adopting a basic logical rule such as modus ponens, one should use the same rule in metalogic. To make it easy to understand the problem, I emphasize this point, that one should use the same rule in meta-logic. This can be done by adding the specific instances of MP, modest ponens, that are needed. But this results in infinite regress, as it is shown by Lewis Carroll. It is famous that it's not possible to express, to state all the instances of MP that you need. Or adding the rule as a schema. You can add the rule, the infinite rule, a rule with infinite instances. You can add the rule itself as a schema which resolves, what is the problem here? Which results in the problem of understanding an infinite rule that we address below. I think the main point that connects that two issues is here. What is the rule following paradox? The second issue. This brings us to the rule following paradox, a problem famously explored by Wittgenstein. At its core, the paradox challenges our ability to fix the meaning of a rule, especially an infinite rule, like a logical rule or the summation rule, the main example of Wittgenstein and Kripke. The rule following paradox. Why? How can we understand the meaning of a completely new infinite logical rule? I explained the paradox in the case of logic. The paradox is not about logic, especially, but I use the paradox in the case of philosophy of logic. How can we understand the meaning of a completely new infinite logical rule? A rule with infinitely many instances. Here we are referring to a rule that governs our basic reasoning abilities, a logical rule. A novel logical rule is a basis for reasoning. Adopting, but what does it mean? Adopting a new logical rule is akin to adopting a new language, a completely new rule, not based on any other rules. It is similar to adopting a new language. Just as learning and using a completely new language can be challenging, embracing a fundamental logical rule poses similar difficulties. How can we translate a completely new language to our language? It's not something we can do, at least not in isolation. A logical rule, by its nature, has infinite instances, as Wittgenstein explained in his famous book, Philosophical Investigation. A logical rule by its nature has infinite instances, and no single act of intention or interpretation can fully capture its meaning, especially from a naturalistic perspective. We want a scientific description of learning a rule, a new rule, a scientific description, a naturalistic perspective, as shown by Wittgenstein and elaborated by Kripke. How have humans managed to fix the meaning of our intuitive logic? Intuitive logic is the logic that Kripke speaks about. the basis for formal logical rules that we use. One proposed solution is that it is a matter of social cooperation over time. It is a matter of evolution. The meaning of logical rules is not determined by individual acts of reasoning, but emerges from shared practices and collective understanding. This social dimension suggests that logical rules are deeply embedded in our communal practices, making them resistant to sudden or arbitrary revision. Classical logic is, because of this, is classical, is standard. Or any logic that you prefer. You may insist that classical logic does not present the real ability of human in reasoning. Leads to an intriguing implication. One cannot simply adopt a completely new logical rule. The meaning of the logical constant involved in that rule is not something that can be fixed independently of our existing practices and shared understanding. It is not possible privately and alone. There is no private logical rule. It is an implication of what Wittgenstein says about private language, as I understand. It is very well known that it is not easy to understand Wittgenstein. Possible solution and further reflections. Given these challenges, how might we address the adoption problem and the rule-following paradox? Let me briefly outline two potential avenues, solutions. First, inference coaching. David and Roberts suggest that, just as one might hire an athletics coach to train in physical skills, one could hire an inference coach to train in logical reasoning. They write, it is rational to hire an inference coach to train to infer. In this way, a person could rationally change her inferential practices on the basis of accepting a basic logical principle. While this approach may help individuals learning currently practiced rules, it doesn't fully resolve the problem of introducing completely new logical rules. Another solution, syntactic or proof theoretic means. Another approach is to introduce logical rules through syntactic or proof theoretic methods. As Pravitz notes, if somebody asks why the rule for conjunction introduction is a correct inference rule, one can answer only that this is just part of the meaning of conjunction. Part of the meaning of conjunction. The meaning is determined partly by laying down that a conjunction is proved by proving both conjunct and partly by understanding, and this is very important, by understanding that a proof of a conjunction could always be given in that way. He assumes that there are always canonical proofs for conjunction or for implication rules. He focuses on introduction rules. Why? Yes, I explained it here. Here, the meaning of logical rules is tied to their role within a formal system, which provides a structured framework for understanding and applying them. Meaning of a logical rule is equal to the introduction rules for that constant, logical constant. But there are some famous paradoxes. The most important one, the most famous one is tongue. To avoid paradoxes like tongue, the emphasis is on introduction rules. For example, a proof of if A then B is exactly a proof from the assumption A for B. So if we have such a canonical proof, then the elimination rule for implication is acceptable. Therefore, MP is acceptable. This solution has its problems. It seems that without having an intuitive sense of a rule, one cannot give a formalization of it. Moreover, one may infer if an A, then B from its, for example, contrapositive. So one should assume that there always is a canonical proof for a valid sentence. This approach leads to intuitionistic logic, not classical logic. Proof is important for privates. Canonical proof. Conclusion. When we discuss an existing rule that governs our reasoning as humans, no adoption is necessary. We instinctively follow it. We have a sense of logical rules. We don't need to learn them. However, when faced with a completely new rule governing an unfamiliar logical connective, we must learn a new language with no prior familiarity. In this situation, grasping the meaning of the logical constant involved is not straightforward. This is a job that cannot be done, at least in private. I think the main problem, the main issue is here. Learning a completely new logical rule. But we can have a solution based on evolution and experiences. We observe, learn, and adapt based on feedback. Our goal is to improve our understanding and ensure we are on the right track as we navigate this new territory. We may never get the essence of the rule. Thank you for your attention. Here you see my main references. Paper by Kripke, Berman, and the others. And also the book by Saul Kripke on rules and private language, introduced by Wittgenstein.
Thank you, Murtaza.
These are, yes. Thank you, thank you.
Thank you, Murtaza. Are there any questions?
Hi, can you hear me?
I'm hearing.
Okay. I wanted to ask you about the shift that you thought it was important to solve the adoption problem from the individual to the community. Because as you set up the issue, the problem was how to learn a rule that has infinitely many instances. So I suppose the problem for the individual was that the individual is finite, so how can he encode infinitely many instances? But if that's the problem, I don't see quite well how the shift to the community helps, because the community is bigger than the individual, but it's still going to be a finite object. So if the problem is the contrast between the finitude of the subject and the infinitely many instances of the rule, it seems that the problem is going to persist also when we look at the community as a whole. I think this relates to, I think some people have criticized Kripke's solution on similar grounds, but I thought it's particularly pressing in the way you set up the dialectic.
Yes, you are right. I see the solution by Kripke a practical solution. Anyway, we learn rules. It seems that we learn rules. We can add numbers. We reason. But so the answer is obvious. The answer is yes. We can understand logical rules or any other rules. But the problem is that how can we understand them? Okay. And I see the answer given by Kripke a practical one. It does not necessarily mean that we grasp the whole meaning of a logical rule or the whole meaning of summation. It just means that we have enough, we get enough information to live, to understand each other. And this understanding can grow during time. Okay, so it is, as I can understand Kripke or Wittgenstein, the answer is just a practical one. It does not answer fully the problem. Okay?
Okay, thank you.
Let's thank Murtaza one more time.
Yes.
Thank you, Murtaza. We're gonna have a lunch break for an hour and 15 minutes. So we'll be back at 2:05. But luckily the lunch is right there. So.
ايه حق يعطيك العافيه دكتور راشد. يعطيكم العافيه جميعا.
هل بعض المواضيع دي موجوده عندنا؟
شنو يعني؟
اللي هي الابحاث دي
عندنا الابستراكت موجوده بالموقع.
مش موجود في كل شيء في الموقع مع المؤتمر.
الابستراكت وعن المتحدثين موجود.
لكن العروض هذه موجوده منقوله مباشره.
اي
موجوده على اليوتيوب. موجوده على اليوتيوب. اليوم كان وغدا.
I don't think we met up. Daniel, nice to meet you. Just wondering, is there Wi-Fi that we can access here?
Same question. There is, but you need an ID. We should ask and Ilya than you?
Yeah.
Where's Ilya? We have you. Okay, we got all three. And then Joaquin online. Almost there.
Yeah, almost there. So, how do you travel for dinner?
We're taking you by bus.
Ah, okay.
Yeah.
I have car, by the way.
Oh, nice.
I borrow from my friends.
So I'll send you the location of where we're going.
Uh-huh.
Parking might be difficult, but it's a weekday, so I don't know.
I hope I can find parking. I've been at Mübarekiye yesterday. There were some close parking lots.
Where?
At Mübarekiye.
Oh, so you've been there?
Yeah, yeah.
Okay.
I enjoyed the kebab.
Oh, perfect. So yeah, you don't need the location then?
If you have the exact location of the restaurant, I will use that.
Okay. Do you have WhatsApp?
Yes.
Send me a WhatsApp. I sent an email with my phone number. I can give it to you right now too.
Yes, that would be easier.
Still got a lot of time.
Yeah, I was just gonna look over my notes for a bit.
Yeah, that's right.
Make sure I'm all ready.
I printed extra handouts, but I don't think we'll need them.
Okay.
But just in case.
As long as we have enough. That's good.
I'll take from the...
Okay. هو مسجل بيوتيوب مسجل لايف فتقدر تحصله بعد ما يخلص اللايف راح يصير له ابلود على طول. دشيت موقع المؤتمر. انت عارف موقع المؤتمر؟ في الحين لايف برودكاستنج. حيكون الحين. الله يعطيك العافية. الله يعافيك. هذا من جهد التعليم الإلكتروني. الله يعطيك العافية. الله يعطيك العافية.
Hi, Jillian. I don't know if you can hear me.
I can hear you.
Do we start later?
Yeah, we're starting later. Can you hear me? So we're starting at 5 past.
maybe it matters for the Zoom people.
Oh yeah, you're right.
Right. Oh, thank you.
His embodied voice asked if we were starting later.
La camera out. Federico.
Oh, I've got one.
Oh, brilliant.
Yeah.
I'll just send the slides, the handout in the chat. Need you. We're missing the one for the YouTube clip.
Yeah.
Oh, you already have it. All right, it's my pleasure to introduce our keynote speaker, Gillian Russell. He's giving a talk about the logic of virtual world.
Okay, thanks, Rashad. Hi everyone, it is tremendously exciting to be here in Kuwait with all of you and getting to talk about logic. So thanks very much for being part of this. So I am going to talk about whether or not virtual reality and the experiences that we have in virtual reality give us a reason to revise logic. So I'm going to start out in the first section by talking a bit about Okay, so I'm going to start out in the first section talking a bit about empirical grounds for revising logic, a bit about Quine. Then there's going to be a section when I talk about virtual reality, and just try to give you a sense of what I'm talking about.
What I mean by that kind of experience. Then there's going to be a longer section about logic and how we might change logic, how that might look different. And I guess, what I'm really looking for is, are there any logical truths that would be different? Are there any entailments that would be different? Any rules that we use in logic that would be different? And that's what I would mean by the logic being different. And then some of what I say is going to depend a little bit on what you think about the metaphysics of virtual reality, like whether it's okay to say that objects in virtual reality exist. And so just at the end, I'm going to talk a bit about the metaphysics, but given the audience, this is going to be a talk where I concentrate more on logic and a little bit less on the metaphysics. Okay, so in 1951, in the first version of Two Dogmas of Empiricism, Quine suggested that we could have empirical grounds to revise logic. And the dominant view at the time was that there were really just two kinds of truth. There were the contingent a posteriori synthetic truths, and we established those through observation, experience, through doing science. And on the other hand, there were the necessary a priori analytic truths, which we established through proof, and logic and mathematics were very much on that side. Right? So you wouldn't expect empirical grounds to change what you think about logic. But Quine argued that there were only truths of the first kind, and that the difference between science and logic was really one of degree rather than one of principle. The logical principles are less likely to be revised because they are more central to the web of belief, meaning that changing them would cause more disturbance, it would be less conservative. But still, and now I'm quoting Quine, revision even of the logical law of the excluded middle has been proposed as a means of simplifying quantum mechanics. And what difference is there in principle between such a shift and the shift whereby Kepler superseded Ptolemy, or Einstein Newton, or Darwin Aristotle. Okay, today, as I know that you all know, there are many proposals for revising logic, but often the arguments aren't especially empirical. So they might depend on, say, a certain philosophy of mathematics, or they might be based on set theoretic or semantic paradoxes. But for a long time, the empirical grounds that was taken most seriously for revising logic was quantum mechanics. And so here I'm quoting Putnam from Is Logic Empirical? I want to raise the question, could some of the necessary truths of logic ever turn out to be false for empirical reasons? I shall argue that the answer to this question is in the affirmative, and that logic is, in a certain sense, a natural science. But even though Quine was sort of interested in the idea that quantum mechanics might make us revise logic and thought, in principle, it could work, he's not convinced by that particular case. So he says, whatever the technical merits of the case, I would cite again the maxim of minimum mutilation as a deterring consideration. I do place the claims of physics somewhat above those of set theory. It's a question of the remoteness from the data of observation. Physics is less remote than set theory. But in any event, let us not underestimate the price of a deviant logic. The price is perhaps not quite prohibitive, but the returns had better be good. Okay, so I want to suggest, like within this framework, that don't worry about quantum mechanics, instead think about virtual reality and the kind of experiences you can have in virtual reality. I think those kind of experiences could give us grounds to revise logic. So let me talk a little bit about what I mean by virtual reality. And in fact, let me ask, how many people in the room have ever put on a virtual reality headset and tried it? Okay, somewhere around half, I'm thinking? Okay. So this set is very much aimed at people who've never done it, right? So, in order to experience virtual reality at the moment, you have to put on a virtual reality headset. So you may have seen pictures of them, but it kind of looks like a set of goggles that are opaque, and you pull it on over your head, and then it covers your eyes, and there'll be like headphones or a speaker that goes close to your ears. Okay, I have this section that I'm going to read out about what it's like to put on this virtual reality headset. Okay, let's say that before you put the headset on, you are standing in a familiar but sparsely furnished room. Perhaps your living room, with much of the furniture pushed back against the walls. You pick up the headset, which looks like a heavy pair of opaque goggles with a strap that goes around the back of your head and a speaker close to your ear. Before you put them on, your visual field contains the room. Perhaps you can see where the carpet meets the wall a few feet away, the edge of your coffee table, a couple of pictures, and the sunlight hitting them from your eye-level living room window. Perhaps you can hear people walking past in the street outside. Then you close your eyes to pull on the headset, and when you open them again, things are visually and hourly different. It appears to you that you're in a much larger space, in the middle of a warehouse, and the walls are further away, the ceiling much higher. The floor is concrete, not carpet. The light is coming from overhead skylights rather than from the eye-level living room window. You turn around and see that the warehouse is open to a forest behind you. Taking a step towards the forest, you realize you can no longer hear the people walking past outside, but instead the sound of dirt bikes revving, and in the background, rising electronic music. Your life now has a soundtrack, and not only in your head. Okay, in some ways, it is as if you kind of blinked and you woke up in a different place. Like if you fainted at school and you wake up in the nurse's office, or if you were chloroformed by aliens and then you've been abducted and you wake up on a spaceship, right? It's like suddenly you're somewhere new. But it's not just the space around you that has changed, okay? So you look down at your own body and see that you are now wearing red motorcycle leathers and boots. You bring your hand up before your eyes and see that it has become a blue claw with long yellow talons. You can control your claw just like you normally do your hand. Clench your fist, and the claw clenches. Clap your hands together, and suddenly your claw hand holds a white gun with red text reading laser on the side. Twitch your index finger, and the gun fires red light, making a pew-pew sound and blowing a noisy hole in the warehouse wall. Outside, the ground shakes, the light shifts, an enormous angry eye looks at you through the hole you just made. Uh-oh. So, I said that in some ways, moving into virtual reality feels like suddenly going to a different place. But there are also some ways in which it's very different from that. So there are three that I'm going to mention that are like listed on the top of the second page of the handout. So first of all, virtual reality is not perfect, and in some ways it can be a little bit blurry or a little bit cartoonish. Maybe it can be glitchy in some ways. And so that's enough to like give it away, that you're not just in a different place. But it seems clear that that is like the limitations of current technology. And we could eventually get to a place where it's impossible to tell whether you're in virtual reality or in real life. So right now, I can always like put up my hand and try and move the headset off. And if I'm in virtual reality, I'll be able to take the headset off. But if at some point we're able to experience virtual reality through a chip that gets inserted in our brain, then that might not be possible, right? And since it will get less glitchy, less cartoonish, those tells will go away. But a second way in which virtual reality is different from just going somewhere new is that the virtual space remains dependent on the space that you started out in. So this is most obvious if you didn't clear your furniture away carefully enough, and then you trip over your coffee table when you're playing some game of virtual reality, right? Then you're definitely going to notice that the virtual world is like still dependent on the real world. You still have to eat for real in the real world. You can't just eat in virtual reality. You still have to go to the bathroom in the real world. You can't just stay in virtual reality. And I think a sort of useful thought experiment is to imagine if the politicians in New Zealand decided that they were worried about all the nuclear weapons in the world, and like the best way to protect New Zealand citizens would be to start a colony on Mars, which will like take them away from the dangers on Earth and like move New Zealand citizens to there. And then the opposition said, you know what would be cheaper than building a colony on Mars? We could build a colony in virtual reality and just put all the New Zealand citizens in there, right? That's not going to work. Right? You're still exposed to whatever's going on in the location, the real location you start out in when you're in virtual reality. Okay. Third feature of virtual reality that's different from just being in a different location is the one that I really want to emphasize in this talk, and that is going to be relevant to the way in which we need a new logic. And so what I've put here is that facts about VR objects, virtual reality objects, can be person relative. So let me tell you a little bit about how I discovered this. It's most obvious when you're in a social virtual reality space interacting with other real people. So during the pandemic, I was part of a virtual reality group of philosophers, and we would meet up once a week somewhere in virtual reality and kind of play games and talk about philosophy and all that stuff. We were in like all kinds of different places around the world, in the US, in Australia, in the UK, but we would meet up in one virtual reality room, and there we could talk to each other. We could see each other's avatars, so we couldn't see, what we actually looked like, but we would have little cartoon bodies, and we could move around and interact with the environment together. And one day, we were exploring this space that looked like it was outside. So we're in a big field. And in the field, there are lots of hot air balloons. And every few minutes, the hot air balloons together all rise up into the air. And if you get in the basket of one of the hot air balloons and it goes up, then you get a nice view of the countryside around. You can see a lot further. So we were doing this and getting in the balloons and going up. And at one point, somebody said, oh, look, the balloons are going up again. And somebody else said, what are you talking about? They've been up for the last 2 minutes. And we gradually realized through interacting that the balloons were not on the ground at the same time for all of us. So sometimes it would seem to say half the group that the balloons were up in the air, but the other half of the group thought they were on the ground, and vice versa. It seemed to us that this was probably just like an element of the environment that the designers of the game had decided or failed to sync between the different headsets, and so we were having experiences that were different in these ways. But this is something that you could quite intentionally put into VR experience. So for example, if you're exploring a museum with a friend and your friend's first language is different from your first language, then you could put the signs in the museum in different languages for different people. Right? Or if one of you is colorblind and the other one is not, it might make sense, it might make a game more accessible to have the colors be different for one person than they are for another person. It's also something that might be less benign. So imagine that you are shopping in a virtual reality supermarket. It's a bit like shopping online, except that to do it, you walk around inside the supermarket and you can see all the products and you can put them in your shopping basket by, say, tapping them in a certain way. So just the way that advertising is targeted now, so advertisers can pay to have certain products look a little bit clearer, look a little bit brighter, look a little bit better. It might not even be like consciously noticeable, but there's a certain sort of halo effect around certain products where they just look more attractive, right? And that could be different from person to person. Okay, so it's this effect that I want to suggest could motivate a new logic. It feels like a certain kind of relativism that you don't get, or you might think you don't get in real life. And just to have a sort of concrete case to discuss on the table, let's think about this situation. So there's one hot air balloon, and there are two people looking at it. We'll call them Cal and Dingo. Okay? And to Cal, the hot air balloon looks red. And to Dingo, it doesn't look red, it looks blue. Okay? Okay, so that's our basic situation. How do we get from there to thoughts about a new logic? Well, here's some sort of preliminaries. First of all, if objects can possess properties in a person-relative way, then the truth of some propositions is going to be person-relative as well. So think about the proposition expressed by balloon A is red, right? And you might think of that as the Russellian pair. You've got balloon A, you've got the property of being red. That proposition is going to be true if balloon A has that property, if it instantiates that property. False if it doesn't instantiate that property. But it seems clear that it does for Cal, but it doesn't for Dingo. And so the proposition is going to be true relative to Cal, but not true relative to Dingo. And then if propositions can get their truth values in a person-relative way, then it seems clear that the truth conditions of sentences are going to be person-relative as well. So take the sentence, balloon A is red, right? That expresses the proposition that balloon A is red. And that proposition is true relative to Cal, not relative to Dingo. And so the sentence is going to be true relative to Cal, but not relative to Dingo. Okay. So I think this suggests that we might be able to handle these kinds of situations using John McFarlane's assessment sensitivity framework. That's often described as a kind of relativism, but it's a very specific, like precise kind of relativism. Not everything that you would call relativism is a kind of assessment sensitivity. So I want to give you like one standard application of the assessment sensitivity framework that McFarlane uses. And I like this one because it feels very concrete, it feels very vivid, unlike maybe epistemic modals or knowledge attributions. I find this one sort of easier to visualize. So the application is future contingents. So we are talking about sentences that make claims about the future, but the claims that they make about the future, they have to be contingent, not necessary or not impossible. So not tomorrow 2 + 2 will equal 4, but something like tomorrow there will be a space battle, all right? And they're supposed to be contingent, so it could go either way, right? We're assuming there might be a space battle tomorrow, there might not be a space battle tomorrow, but it's not decided yet, right? The future is still open. Okay, so McFarlane says that there are two intuitions that we have about future contingents that are kind of in tension, right? And he calls one the indeterminacy intuition and one the determinacy intuition. So to get the indeterminacy intuition, imagine that we've got this timeline that is drawn on the handout. So we've got day 0, and then moving to the right on the page, we're going into the future, day 1, day 2, day 3. But what's going to happen on day 2 is not determined yet. So the timeline splits. We've got one possible future at the top, one possible future at the bottom. And you can see that on the top, on day 2, that little squibble, that's a space battle that's going on. But then on day 1, we have this little stick figure, that's Alice, right? And Alice is the person who's speaking. She utters 1. So she says, there will be a space battle tomorrow. And we need to think about whether what she says, like that sentence in that context, right, is that true? And there's a sort of natural tendency to say, well, it's not decided yet, right? If there's a space battle tomorrow, then it would be true. If there's not a space battle tomorrow, then it would be false. But we don't know yet, and in fact, it's not determinate yet. So right now, when Alice speaks, there's no truth value, right? It's indeterminate. So that's the indeterminacy intuition. But we also have a determinacy intuition. So this time, consider Bob. Bob is over there on day 3. He's in the top part of day 3, so he's cleaning up after the space battle. And he is thinking about Alice's utterance, the utterance that took place on day 1, and trying to decide, is that true, right? And she said on day 1, there will be a space battle tomorrow. There was a space battle on day 2, which he now has to clean up after. And so he says, right, what she said was true. Right? There was a space battle. She said there would be, so what she said was true. That's the determinacy intuition. But that one utterance, you might think, can't be both indeterminate and also true. So how do we resolve this? And McFarlane's solution is to say that the truth value of that utterance is relative to context of assessment. And what that means is it's relative to the situation in which the person who is trying to decide whether it's true finds themselves. So when it's Alice, and she's on day 1 trying to decide is there will be a space battle tomorrow true, the answer is it's indeterminate relative to that context of assessment. But then on day 3, when we've got Bob, it's determinate relative to his context of assessment that what Alice said on day 1 is true. Okay, so future contingents on this view are assessment sensitive. They get different truth values relative to different contexts of assessment. Okay, I'm claiming that the person relativity of VR makes it suitable for treatment with McFarlane's assessment sensitivity framework. So suppose the utterance this time is Cal saying 2, which is balloon A is red. When 2 is assessed relative to Cal's context, it's true. But relative to Dingo's context, is false. Okay. What does that mean about the logic, right? So far I've been talking about sentences and the truth values and the truth values of propositions. But how does that tell us anything about like what logical truths there are or what entails what, any kind of logical rules? Well, McFarlane's main focus is not logic. So he's interested in like natural language semantics. That's relevant to logic, and he has a few things to say about logic, but it's not like he sees his job as determining logic, right? But he does say a few things about logic, and the framework, the assessment sensitivity framework, is loosely associated with 2 non-standard, like non-classical logics. So one of these is Łukasiewicz's logic, L3. That was developed for thinking about future contingents. It's one on which there's a third truth status, indeterminate. If you negate an indeterminate sentence, you get another indeterminate sentence. If you disjoin indeterminate sentences, you get an indeterminate sentence. And so the law of excluded middle ends up not being a logical truth, and so you have a non-classical logic with indeterminate not being a designated value. Okay. The thing is, the non-standardness from Łukasiewicz's logic really comes from the indeterminacy, from the fact that we have this sentence that is neither true nor false. And it doesn't seem as if what's going on in the virtual reality case is really indeterminacy. So 2 is true for Cal, but false for Dingo. It's not indeterminate for anyone. And we might think that the law of excluded middle is true for both of them. So Cal would say, you know, balloon A is red, or it's not the case that balloon A is red. Yep, that's true. But Dingo would agree with that, right? Okay. And you might even think that, like, virtual reality is surprisingly determinate. Like, lots of things have to be fixed. Like, the objects have to have some color. They have to have some shape. In ways that say, you know, merely fictional entities or other kinds of things you might compare it to, you know, they don't have to be that determinate. Okay, here's a different non-standard logic that seems like it might be helpful. It's Kaplan's logic of demonstratives. So this logic LD was developed for indexicals, words like I and here, and it incorporates these as new logical constants whose truth and denotation conditions make them sensitive to context of use. So the context in which the expression is uttered or written or signed. And the result is that we get some new logical truths and entailments because we have these new logical constants. So the most famous one is the formalization of I am here now. That comes out as a logical truth of the logic of demonstratives. But you also get some interesting examples with indexical operators like actually and now. And so in particular, actually P entails P, and it is now the case that P entails P as well. But the logic of demonstratives is not a perfect fit for a couple of reasons. So one is it's really for use sensitivity rather than assessment sensitivity, so it's a different kind of context sensitivity. And in addition to that, McFarlane distinguishes 2 different kinds of context sensitivity. So there's indexical context sensitivity, and there you get the propositional content of an expression varying with context, as opposed to non-indexical context sensitivity. And there it's just the truth value or the extension of the expression that varies with the context of utterance or the context. LD is for like indexical use sensitivity, but VR looks as if it's about non-indexical assessment sensitivity, because there you seem to have a proposition like the proposition that balloon A is red, and that very proposition gets a different truth value relative to different contexts of assessment. It's not just that the one sentence expresses different propositions relative to different contexts of assessment. Okay, still, we can take inspiration from some of the stuff that was going on with the logic of demonstrative. So let's try this. It's really familiar that propositions get their truth values relative to some things. So it's perfectly normal to say they get different truth values relative to different possible worlds. It is normal, if a little more controversial, to say that they get different truth values relative to different times, right? And then what's like a little shocking about relativism is that they get different truth values relative to different people, okay? So really familiar idea of the intention determined by a proposition is that it's a function from possible worlds to truth values. Slightly fancier, it's a function from possible worlds and times to truth values. And then a little shocking, a little relativist, it's a function from possible worlds, times, and people, like a person, to a truth value, okay? So call that kind of function a fancy intention, right? It's what it's sometimes called in the assessment sensitivity literature. So we're going to think that the proposition expressed by, the proposition expressed by a sentence like balloon A is red determines a fancy intention. So a function from a triple, a world, time, and person to a truth value. Once we've got propositions like that, we can introduce operators which shift those parameters. So I can say, on Friday, balloon A was red, and now I'm assessing the proposition expressed by balloon A as red relative to some time on Friday, right, rather than the time at which I'm speaking. Or I can say possibly balloon A is red, and now what we need is some other possible world where the proposition is true. And when it comes to people, I can say something like for Cal and relativize it to that person. So for Cal, balloon A is red. And then for Cal functions as a kind of de-relativizer. So balloon A is red, that was true relative to one person, not relative to another. But once I put in for Cal, then I've taken out this relativity because I've specified the sort of person that I'm interested in. Okay, if we want to get a little more formal, we can give truth conditions for sentences containing these operators. So we might say, on Friday, phi gets the truth value 1 relative to a triple WTP, if and only if there is some time t star during Friday such that phi gets the truth value 1 at the triple W t star, that is the time in Friday, and the person. And then if we were going to have a person relative operator like for Cal, then we could say for Cal phi gets the truth value 1 at WTP, if and only if phi gets 1 at WT, and then Cal's the person that we're looking at. Okay. If we go beyond that, and we relativize the truth of sentences to context of use, then, and we think of those as quadruples the way Kaplan does, so now we've got a place, a time, a world, and an agent, that is the person speaking or signing or writing the sentence. Then we can introduce not just operators, but indexical operators on the model of now or actually. So in the case of a person, this would be not just for Cal, but for me, right? So the same way I can say now, balloon A is red, and that will be true just in case the proposition balloon A is red is true at the time I'm speaking, right? So for me, balloon A is red will be true just in case balloon A is red for the person speaking, right? For the agent of the context, right? Okay, but now, just as we can go from phi to now phi in the logic of demonstratives, or phi to actually phi in LD, so we can go from phi, balloon A is red, to for me, balloon A is red. And that will be true in all contexts of utterance. Okay, so that would be an entailment in the new logic. And maybe, like, while we're just thinking about logical stuff, like one thing that would fail, that would normally hold if we weren't in virtual reality, is I can, in normal life, I can go from balloon A is red to balloon A is red for Rashid, right? And that would be just fine. But there's like no guarantee that that will preserve truth once we've got one of these assessment-sensitive logics. Okay. Let's see. Okay, I should start to wrap up. So let me just say something a little bit more metaphysical. I've been speaking as if when we invented virtual reality, right, we were introduced to a new part of the universe, right? We extended the universe, and the extension contains these new objects that have special properties. They are person relative. Because of that, we need some kind of new logic. But we wouldn't normally have thought we needed it in sort of normal life before we did that extension. So if we were here and we see a balloon, a hot air balloon out of the window, and I think it looks red, but Rashid thinks it looks blue, right? We think something's gone wrong, right? We don't just think, oh, it's blue for you and red for me, right? We think somebody's hallucinating or not paying attention, or maybe there's some sort of filter on the window. Something could be going on, but we've got to figure it out and solve it. We don't just say, oh, it's blue for you and red for me. right? So I've been talking as if there's this like interesting new kind of object, right? But that could be challenged, right? There's a whole slew of different views you might have about the metaphysics of virtual reality that would undermine the kind of things that I've been assuming. So one thing I imagine somebody saying is, no, both Cal and Dingo are making a mistake. They're both wrong, right? To say balloon A is red, that's false. To say balloon A is not red, that's false, because there's no balloon A, right? There are no virtual objects, they're not real, and so there's no problem, and so we don't have to do any of this stuff, right? That's a possibility. A different kind of objector might, instead of saying there's no object there, say there's two objects there, right? So maybe there's like the visual image or the display in one headset, and that's red, and there's the visual image or the display in the other headset, and that's blue, but you have no need for relativism because there's no one object that is like red for one person and blue for another. So that's another like metaphysical way out of this that you might go. I think there's genuinely lots of interesting stuff to be talked about with these questions, and I think it's sort of an open question, how we should talk about virtual reality objects. But I think it's also worth thinking that if you're Quine, and you hold kind of Quinean views about existence, then you might think you have good reason to posit that they exist. So Quine thinks that what we say exists should be part of this conceptual framework that helps us predict and explain our experience. So he says, as an empiricist, I continue to think of the conceptual scheme of science as a tool, ultimately for predicting future experience in the light of past experience. Physical objects are conceptually imported into the situation as convenient intermediaries, not by definition in terms of experience, but simply as irreducible posits, comparable epistemologically to the gods of Homer. So I think if you accept this kind of Quinean ontological view, then the more time we spend in VR, and the more like consistent it is, the more we start spending money on virtual objects and getting emotionally involved with them, playing games, getting like goals that involve virtual reality objects, then the better it explains our experience to posit that they exist. And so it seems to me that if you hold Quinean views about the epistemology of logic, and also Quinean views about ontology, and you apply those to virtual reality, then you might well end up thinking that we need new logic to explain VR experience. Okay, that's it. Thank you.
Time for questions.
Roger, that was nice. Leaving virtual reality aside for a moment, just speaking of physics, there's actually a worldview and a logic that does what you do already, which is Jain logic. So in Jain physics, reality is inherently multifaceted, and people can have different views about the same object from different facets. For example, the self is permanent, the self is not permanent, there is no self. And all these are equally correct with respect to a facet, so you can see the relativism. And the Jains actually worked out a rather amazing seven-valued logic for this. But we can talk about 1/7, but in fact there's a very close connection between the Jain logic and many-valued discursive logic, a version of a one-cloud of power consistent logic. And some of those details we worked out in some of the things that have been worked out in detail by various people, including me, I must confess.
Okay.
Okay.
Good.
But it may well be that the kind of logic that you want you can find something like it already in the literature.
Yeah, I'd be very interested in seeing that. When I imagine like the interlocutor with this paper, when I imagine the audience, I usually imagine them thinking, relativism's false. I imagine like Fodor saying, I hate relativism, it's stupid, right? And thinking, we were never going to have fancy intentions as part of our like assessment sensitivity for I don't know, epistemic modals or something like this, because, you know, we just don't think the world is relativistic. And like coming along and saying, yeah, but look at VR. Like it's explicitly built in ways that, you know, the way people don't like to think the real world is, it is, right? But of course, there's the possibility that that's not the metaphysician I'm talking to. That, I mean, some people already think the world is relativistic, and then I think there are like some kind of edge cases with, so even if you're not inclined to think that relativism's true, if you look at something like a rainbow, where the location of the rainbow, or where it appears to be, depends on where you are, it can get kind of tempting to say that some sort of relativism goes on with rainbows, or maybe that rainbows don't exist. But and so, yeah, I mean, at some point, I think I need to back off and say, it's not like I have an argument that the world is not relative already, right? And at some point, it's going to have to be, yeah, so VR makes it even clearer that we need some new logic, but.
Well, relativism is also clear about something. What's interesting about the James view is that it's true about everything. That everything is relative to everything. And then, of course, it gets much more complicated because you can ask questions about if it's relative to you that so-and-so, is it relative to you that it's relative to me so-and-so? So there's a question of the
iteration of the, yeah.
relativity operators, which is a place that James didn't go, but, you know, modern logicians can go there.
Yeah, so I talked about like the for me as being kind of absolutizing, yeah. Right? And then, but is it really? Is the, yeah, okay.
Thanks. Maybe this is a question for you, or maybe it's a question for McFarlane, I'm not sure. But I wanted to ask about the indexical use sensitivity versus non-indexical assessments, the sensitivity and that distinction again.
Okay.
So why wouldn't you want to just collapse, why wouldn't you want to say that when it comes, okay, why wouldn't you want to say that when it comes to the proposition balloon A and then the property of being red, why wouldn't you want to say that in VR maybe certain properties that normally aren't indexical have this kind of like hidden indexical structure, and I don't know, like the bottle is, I say the bottle is near, you say the bottle is far, and it's not really a proposition about a property of the bottle so much as it is different propositions expressing different, I mean, maybe that's what you get to in the end in the objection that you're arguing.
Yeah, I mean, it sounds wrong, right? So if I say, you know, balloon A is red, and he's saying balloon A is blue, right, or not red, I'm really disinclined to say like not red in his words means what I mean by red in my words, especially given that, you know, we learned the word red in the real world, and so I'm inclined to think that. You know, the proposition just gets different truth values relative to different people. It's not that it would be completely impossible to go that way. It just doesn't feel right to me. There's still going to be some indexicals, like, you know, the for me, right? Obviously, me is going to mean something different when I say it than when you say it.
Thanks for the talk. I liked it a lot. I was curious about when you said that L3 does not seem to get things right.
Okay.
Because there seems to be no indeterminacy in VR. The way I was looking at the example, one could define kind of objectivity in VR as
true for everyone.
Truth for everyone. So A or not A would mean A is true for everyone, or not A is true for everyone. And
that would be false. Yeah.
That would be yes. So I just wanted to know if you think that could be another way of understanding that.
Yeah, no, that's a real idea. I think it could be. There's almost like a supervaluation kind of approach. Yeah.
I guess I just wanted to ask about the extent to which you were thinking about this proposal as involving a revision of logic. So like you introduced the topic by talking about Quine and quantum physics, and maybe this gives us reason to drop logic's good middle, or maybe distribute it, whatever. But then the system that we get, and I think this is also true of Kaplan's, is, I would think it's, maybe an extension of logic, so it's a non-classical.
Okay, so I think Kaplan's is a bit more than that.
Okay.
So there are new logical truths and new entailments involving the new logical concepts. Right? So that feels like an extension. Yeah. But then also there's the idea of necessitation. So you can no longer go from like phi as a logical truth to necessarily phi as a logical truth. So that is like a familiar standard model rule that fails. Because now you have these like contingent logical truths like I am here now, or if actually phi then phi, and I think you're going to get the same thing if you ask this margin note, which I didn't go into just because I looked at my watch and realized I didn't have much time. So I think you're going to get a similar phenomenon with phi. If that's a logical truth, it doesn't just mean you can go to for everyone phi. And there's a counter example there, but it takes a little bit of thinking to get your head around it. So if you have a conditional, and this is a conditional, for me, balloon A is red, then balloon A is red. Right? That's going to come out as a logical truth, but if you add for everyone to that, the result is not a logical truth, because it's false for dingo, and the me and cow is words means cow. So I think you are, it's not like we have a form E operator that's limited or anything like that, but the normal thought in reality is like, if balloon A is red, then for everyone balloon A is red, something like that. Or if balloon A is red, or it's not the case that balloon A is red, then you can go to for everyone that. Right? And I think that, just like necessitation, just like the for everyone thing is going to fail in this kind of logic. So there will be failures of stuff as well as new stuff with the new logical expressions.
Yeah, I guess I was thinking the for everyone operator wasn't really there prior to the introduction of these other relative things, but thanks.
Let's thank Gillian one more time. This one is for the live streaming. So also yeah.
Okay. And this one.
You can put in your box. Right. Our next speaker is Elias Zardini, and he's going to talk to us about unstable knowledge.
Okay.
All yours.
Okay. Thank you very much. I apologize when I submitted the abstract for the conference. I didn't know that the time slots were so short. Otherwise, I wouldn't have submitted this paper because it's a lot of material that is not really appropriate for a 20-minute presentation. So what I decided to do was to pick and choose the themes in this material that I think are of most interest for this audience, including attempted criticism to Graham's positions. So also, when I show a single slide, mostly follow what I'm saying rather than looking at the slide, because I'm going to have to skip things even within a single slide. I apologize for that. So this talk is about the nowhere paradox and about how different non-classical logics can deal with the nowhere paradox. And then I'm going to try to use what results of that from my own logic to try to push a bit further certain conceptual aspects of my own proposal. So what I'm going to cover today is, of course, giving you is basically the first main section, this half of the second one, and the last main section. So I'm going to set up the ground for the nowhere paradox, then I'm going to show you the version of the nowhere paradox we work with. Then, as I said, I'm going to try to mount a little criticism of a dialectic approach to the nowhere paradox. And then I'm going to skip to the last section. And after explaining how my own non-classical approach deals with the nowhere paradox, I'm going to try to argue that for many paradoxical sentences, we actually have good reasons to accept the sentence or its negation. And at the very end, I'm going to try to use this thesis to argue for a new description of the fundamental status that paradoxical sentences have. Okay. So first thing, so we're going to talk about knowledge, and when I say knowledge, we mean something existentially quantified, knowledge by someone at some time. And then we're going to talk, perhaps a bit strangely, of knowledge of sentences. The official logical format is going to be that a certain sentence A is known. And when I say that A is known, I don't mean the one is well acquainted with A. I mean the one knows that what A says is the case. Okay, then in terms of, we're going to do all this in a semi-formal language. So we're going to use big K as this knowledge predicate for a sentence. We're going to assume, as always in the case of the paradoxes, that for every sentence in the language also has a name for the sentence, which is going to be within corner quotes. And then, as we always have also in the case of the paradoxes, we're going to assume that we have enough expressive resources so we have a self-reference. So in particular, in this case, we're going to assume that we have a sentence kappa that is just identical with a sentence that refers to kappa and says the kappa is not known. Okay, that's going to be the nowhere sentence. Okay, now we have all the materials to run the paradox. Well, suppose for reductio the kappa is known, then we can apply a principle of activity of knowledge that if a sentence is known, then the sentence holds. So we apply to kappa, we get kappa that is kappa is not known. So from kappa is known, we can derive its negation. So by applying the intuitionistically acceptable version of reductio, we can infer on no assumption the kappa is not known. But now we infer on no assumption. I mean, we proved it. It's a theorem of the system. And now we appeal to a second principle about knowledge, which I call proof is knowledge, as a kind of version of normality that Gillian also talked about in a different context. So if something is provable, is a theorem of the system, then it's also provable, it's also a theorem of the system that that sentence is known. So we apply this to kappa, we get the kappa is known, and now we have a contradiction on our assumption. Kappa is both known and not known. This is the nowhere paradox. That's it. So there, I'm mostly interested, of course, there are lots of different approaches to the paradox. I'm mostly interested in paradoxes that try to preserve the naive principles, the two naive principles about knowledge that we've seen in the paradox, and instead try to modify the logic so that these principles are co-tenable. In particular, as many of you already know, there are two kind of standard non-classical approaches to paradoxes of truth and therefore paradoxes of knowledge. One rejects the lowest excluded middle, and the other one, which is the only one I'm going to focus on today in addition to my own approach. The other main approach is the one also Graham presented in his talk, is a dialectic approach that keeps the lowest good in the middle. What he rejects is the law of non-contradiction, in the sense that the contradictions are now acceptable. They don't entail everything, well, exactly as Graham explained in his own talk. Focusing on a dialectic approach, the idea of a dialectic approach is the natural application to the nowhere paradox of what we see in the case of a semantic paradox is simply to accept the final contradiction of the paradox. So the dialectist, a standard dialectist, I take it will say that the nowhere sentence is both known and not known. Now comes my little criticism. Where is it? There it is. So consider, I think the following principle is very plausible, even if one is in general open to possibility of true contradictions. Is the principle that acceptance requires rejection of not knowledge. So if you accept a sentence, then you should reject, you shouldn't accept that you don't know that sentence. I mean, you can see that contrapositively. I mean, suppose that you think that you don't know a sentence, then you must think that your reasons are too bad for accepting the sentence. But if you accept that your reasons are too bad, then you shouldn't accept the sentence. You don't have, sorry, this, I apologize. So you don't have good enough reason to accept that sentence. So going back contrapositively, if you do accept a sentence, you shouldn't also accept that you don't know the sentence. So you should, in that sense, you should reject that you don't know that sentence. So I think this principle is pretty plausible, even if one is in general open to true contradictions. But of course, when we apply to the specific extreme case of kappa, we get a disaster, because the dialectist accepts both kappa and its negation, so he accepts kappa, and by this principle he should reject that he doesn't know kappa, but he doesn't know kappa just is effectively kappa. So he should both accept kappa and reject kappa, which even in the standard dialectist framework is not something acceptable. It's a sort of pragmatic incoherence of both having the sentence in your mind as accepted and not having it in your mind as accepted. And it's even, I mean, if you might relax things there, but even if you relax things there, you still have that if you do reject kappa, then consider that not kappa, which is basically equivalent to kappa is known, entails kappa. So if you reject kappa, you should also reject what entails kappa. So you should also reject the kappa is known, which is not kappa. So you should not only reject kappa, but also reject not kappa, while at the same time you accept the lowest good in the middle, and that really seems a logical inconsistency, because you accept the lowest good in the middle, but you firmly reject both one disjunct and the other disjunct. So that's why I think at least the nowhere paradox might throw up a little interesting extra challenge for a dialectist that wasn't there in the case of the liar paradox or other standard semantic paradoxes. Now let me, having made this little criticism, let me very briefly introduce my own approach to this issue, which is the one that I want to develop in the rest of this talk. So my own approach, I really like to reject an extra principle that is involved in the semantic paradoxes and also in the nowhere paradox, which is the principle of contraction, which basically means that if you have a valid argument with a same premise occurring twice as a premise in the argument, then you still have a valid argument by only have that premise occurring once in the argument. So by contracting, as it were, the two occurrences of a premise into a single occurrence. For those of you that are more technically inclined, really the core logic of the system is the multiplicative sentential fragment of affine logics. And we don't need to, they're very similar to linear logics if you've heard about them, but we don't really need to go into many details for my purposes. So interestingly, this system accepts both the law of excluded middle and the law of non-contradiction. The problem with the nowhere paradox is the application of reductio from this perspective. This is so because basically what's really, you can really deny phi. The first principle should be that you can really deny phi if phi leads to a contradiction. And because of a law of non-contradiction, if phi leads to a contradiction, then it cannot be true, so it must be false. So that's the good principle. The good principle gives you reductio if you can use phi, if phi entails its own negation, then if you can use phi again also to keep phi fixed, then phi is going to give you both phi and its negation, so it's going to give you a contradiction. But in order to do this, we need to use phi twice, which formally means an application of contraction. So reductio is only a good principle if contraction is valid. If contraction is not valid, then reductio loses its, what I think is its most natural justification in terms of law of non-contradiction. So that's why on this approach is perfectly justified, since contraction fails, it's perfectly justified to reject the reductio step in the argument. So that's from a more formal point of view. From a more philosophical point of view, I want to mention that the idea of failure of contraction, which might come across initially as a bit strange, can be motivated by thinking of the sentences that fail to contract as expressing some sort of unstable state of affairs, where this means very roughly that a state of affairs is unstable if it causes another state of affairs with which it does not co-obtain. So you don't have them together, but one causes the other. So we don't have time to go into this, but if you have this metaphysical picture in the background, I think it's quite arguable and understandable that then at the logical level you have failure of contraction. Okay, now big jump. But very importantly, on this approach, contrary to the standard non-classical approaches, paradoxical sentences are consistent, which means they don't lead to a contradiction. One can consistently assume kappa, no logical problem with that. One can consistently assume not kappa, no logical problem with that. So one doesn't, because a paradoxical sentence is consistent, one doesn't have to reject kappa, contrary to anti-alithic approaches, and because the negation of kappa is also consistent, it doesn't lead to a contradiction, one doesn't need to accept kappa either, contrary to the alithic approaches. So at least from a point of view of logic, it's okay to accept these sentences. One doesn't get involved into an inconsistency. Now I want to strengthen this position. So it's not only from the point of view of logic, the assumption is consistent. I also, in another part of a talk that I'm going to skip right now, I'm also going to argue that in spite of the instability of the underlying states of affairs, one can accept a sentence and just stick to the sentence without inferring its negation. One can quite coherently do that. That's what I would argue in the next part of the talk, but again, I'm simply, having stated a thesis, I'm simply going to assume it for lack of time. And this is the last jump we're going to make. So, by the way, on the slides we have this notion, this character, the abibiotist. That's the position, that's the name I give to my position in its totality. So not only from the formal point of view, failure of contraction, but motivated in terms of the instability of the states of affairs. This is gonna label in the slides as the abibiotist position, because abebaios in Greek means unstable. So I'm following the example of the lithism to give Greek-sounding name to my position. So up to now I've argued is logically consistent to accept kappa, and it's also one can accept it and remain fixed in that acceptance. Now I want to go a bit more epistemological, asking the question, do we have, apart from it being coherent, do we actually have a good reason to accept kappa? And I'd like to argue that yes, we do. How? Take the low excluded middle. By the low excluded middle, which I already said is valid in the system, we have either kappa or not kappa. And then, of course, because of activity of the principle of activity of knowledge, we know that not kappa entails kappa. But then, by applying a very plausible principle of disjunction, we get what I call the self-disjunction of kappa with itself. We have kappa or kappa. And that's a very good reason for accepting kappa. It's not only a good defeasible reason, it's not even defeasible, it's an infallible reason. Right? You know there are only two possibilities, either kappa or kappa. So if you accept kappa, whichever of the two possibilities realized, you're going to be right. So it's an infallible reason for accepting kappa. Now, many of you might wonder, why are you calling it infallible reason? Why don't you just say it's a logical reason, that it just follows from kappa or kappa that you have kappa? Well, it's because it doesn't follow. In a non-contractive logic, it doesn't follow from the self-disjunction of kappa. The single kappa doesn't follow. Now, here you have a bit of an explanation that, for lack of time, I'm going to skip in the slides. But you have to keep in mind that in a non-contractive logic, self-disjunctions are very weak. In particular, they are so weak that in the other part of the talk that I had to skip, one can show that not only we have the self-disjunction of kappa, we also have the self-disjunction of not kappa. So just as we have infallible reasons for accepting kappa given by the self-disjunction kappa or kappa, we also have infallible reasons for accepting not kappa given by the self-disjunction not kappa or not kappa. So this generates a very interesting situation, because when confronted with the question what to believe about kappa, we have, as I just argued, excellent reason for believing kappa, but also excellent reason for believing not kappa. And because of the law of non-contradiction, we cannot do both things. So it's a situation where we have very good reasons for doing something and very good reason for doing something incompatible with the first course of action. And that's a standard representation of what the choice is. Only we're used to choice in the practical realm. When we have to decide what to do, then of course in the normal run of cases, we have at our disposal at least two incompatible courses of actions. Here it's not about what to do. Here it's about what to believe. So it's a mind to word direction of fit rather than a word to mind direction of fit. And for that reason, I think we can call the present situation a situation of theoretical choice, where it's a choice in this formal sense I just explained. It's a choice not in terms of what to do, but in terms of what to believe, what to judge, and all these kind of representational states. So that's why I call it a theoretical choice. And you might think that this is idiosyncratic and perhaps it's not very serious, but actually I think that this is totally independently motivated by much more mundane cases. One of my favorite examples is when we go to one of these restaurants, they have a daily menu deal. Then what we pay for the daily menu, and maybe the choice is between fish or meat. Then we have of course, we have a practical choice about what to eat, but we also have a theoretical choice when we order about the first person future tense statement, I shall eat meat or I shall eat fish. That's something theoretical about what I'm going to do in the future. I can decide to believe either one thing or the other thing, the two things being incompatible between themselves. So it's, I think what we are having here in the case of kappa is actually something that we're already very familiar with in ordinary life. Now, I like to argue that the situation of theoretical choice is exemplified not just by kappa as a rarity, but is actually very common in the case of the paradoxes of self-reference. The very ambitious thesis that is still at the speculative stage is that every time we have genuine ungroundedness in the standard technical Kripkean sense, then we do have this situation of freedom, of theoretical choice. But I like to argue today for the thesis only by going back from the nowhere paradox to the semantic paradoxes, where I think the thesis can already be established, and establish it by taking as an example the liar sentence. Sentence lambda that says of itself that is not true. Here I use T as a truth predicate, and the up arrows indicate the states of affairs expressed by the sentence within the up arrows. That PSA principle is the principle of semantic assent. By semantic assent, the states of affairs lambda, for example, causes the states of affairs the lambda is true. Reality causes what is true, standard Aristotelian principle. But of course, in the case of lambda, lambda doesn't really co-obtain with this effect because they are incompatible. Lambda says of itself that is not true, so it's not going to co-obtain with the states of affairs that says that is true. But not co-obtain, that requires the negation of a conjunction. So we're going to have the negation of the conjunction lambda and T lambda. And then by transparency of truth, that's going to give the negation of the self-conjunction of lambda, and by standard De Morgan rule that is acceptable for a non-contractive theory, we get the self-disjunction of not lambda. So again, we have excellent infallible reasons for accepting not lambda. And of course, the same reasoning concerning instability is going to deliver us the self-disjunction of lambda with itself. So we also have excellent infallible reasons for accepting lambda. And this is just an example. Of course, it generalizes to at least to all semantic paradoxes in virtues of the transparency property of truth. So the general thesis that still needs to be explored for 3 minutes. Yeah, that still needs to be explored for in the case of knowledge will be the ungroundedness in general gives us freedom of choice. Okay. Now I like to use these reasons we've discovered to also give a fundamental description of the status of paradoxical sentences. Now, of course, one answer I could give you with respect to the question, is lambda true or false? I could just use my freedom of choice and decide that lambda is true and tell you lambda is true. But that, of course, I've argued is justified epistemically. It doesn't seem to be the fundamental status of lambda. It's not that the fundamental status of lambda is that it's true. I could have just as well told you that lambda is false by making the opposite choice. So that doesn't seem to get to the bottom of the issue. I think we get an indication about how to get to the bottom of the issue by going back to the restaurant example, when we pay for the daily menu. That's the fundamental description of whether I shall have meat or fish. Of course, it's not that I shall have meat or that I shall have fish. The fundamental description of my of what I will do, given my new normative status of having paid for the daily menu, is that either I'll have fish or I'll have meat. Well, importantly, either is not the normal disjunction we are familiar from in standard logic, but it's what is called in linguistics free choice disjunction. There's very interesting logical properties of entailing each of the disjunct, but not entailing them both at the same time, as it were. So one can choose which disjunct to infer, but if one infers one disjunct, one is no longer allowed to infer the other disjunct. That's fundamentally the formal structure of a free choice disjunction. And my proposal is to use this very nice conceptual tool that we have in the restaurants and in ordinary life of free choice disjunction, and use it maybe for the first time in philosophy, actually to formulate a philosophical thesis about reality, in particular about the fundamental status of paradoxical sentences. So my proposal is to say that lambda is not both true and false, it's not that it's neither true nor false, by using either or in the free choice sense. The fundamental status of lambda is that it's either true or false. And with this thesis, I finish my talk. Thanks. Here you have some references.
We have time for one quick question. Federico.
I was wondering about your criticism to the analytic position.
Why?
So I was wondering whether, so the problem is that you don't want to accept that you can both accept and reject, and that that causes you trouble for the dialetheist.
Yeah.
But what if the dialetheist is also dialetheist about acceptance and rejection? Then that dialetheist could still accept IRN, could, of course, there's a pragmatic contradiction, but that contradiction is not problematic for her because it also accepts. And moreover, you don't have to deal with potentials, for example, to exclude the middle that you mentioned.
I think I will still raise the issue with this last point, with exclude the middle, because here rejection is not something that does also someone who is agnostic. Here rejection is someone who conclusively wants to rule out the truth of the sentence in question. So if rejection is this attitude of really ruling out the truth of that sentence, then I do think that rejecting both a sentence and its negation is in great tension with accepting the disjunction, the instance of excluding middle. It wouldn't be if rejection is something that is compatible with agnosticism, right? Because we can be agnostic about A, agnostic about B, but still know that it's either A or B. So if we have this weaker attitude of suspending judgment, then I don't think that it would be a problem. In this context, rejection can be interpreted much more strongly as really ruling out that the sentence is true. And if you do that, I don't see how you can rule out that you can rule out kappa in this strong sense, rule out not kappa, but still accept either kappa or not kappa. That's what I obscurely refer here as a Lem-style logical inconsistency, because you are
okay, it's not an attitude. It's not possible to. But that means.
Well, no, I don't want to stipulate it. Just I want to make clear that here we are talking about rejection in a stronger sense than simple suspension of judgment. Okay. And I'm claiming tentatively that in this strong sense is not coherent to reject A, reject B, and at the same time accept the disjunction A or B. That would be the argument, but I don't know if it works.
Let's thank Elia one more time.
Thank you.
We're going to have a 15-minute break and then 2 25-minute talks left. So we'll be back at 3:40.
I'm missing something there. And it's not you I'm missing, by the way, just to clarify. What's the connection between contractual and reduction here? In case
some point.
Yeah, maybe.
In order, yeah, exactly.
That would be nice.
Spread the misery.
Yeah. Our next session is by Abu Bakr Deniz, and he's going to talk about towards a protologic, a transcendental analysis of formal systems.
Thank you. Thank you, Rashid, for organizing such an event, and thank you for feeding us with such quality food. Today I'm going to talk about the protologic, which is kind of underlying logic for all formal system. I'm going to talk about the possibility of that logic and how can we approach or how can we argue that logic. So this talk will be conclusory in a sense that I'm not going to present what is protologic, what are the principles and what are the connectives or what are the system we have to suppose, but how can we approach formal systems to look for such an underlying logic? Yeah. So for centuries, logic has been developed through system building, and classical logic was historically assumed to be the universal structure of reasoning. However, over time, the emergence of non-classical logics, such as intuitionistic, paraconsisting, etc., has demonstrated that logical structures can vary depending on the system that we adopt. And this has led to some contemporary major discussions about the logical pluralism and the philosophy of logic, some arguments for logical anti-exceptionalism, and that kind of discussions. While these debates about the pluralism, monism, or the anti-exceptionalism has shaped much of the contemporary philosophy of logic, I think it overlooks a deeper question. Rather than asking which logic or which logic is correct or is logic has some a priori side, it overlooks the question, what are the necessary conditions that make logical formalization possible at all? So most accounts of logical foundations assume that logic already exists in some form, whether as a reflection of reality, like in realism, or as a construct of human cognition in idealism. However, these accounts do not address the prior question of what allows logic to exist in the first place. So instead of focusing on whether logic is discovered or constructed, I ask what fundamental structures must be in place for any logical system, classical or non-classical, to function coherently. So to answer this, I introduce protologic, a foundational structure that precedes all formal systems. Protologic identifies the minimal conditions necessary for logic to emerge and function. So rather than assuming that the logical systems are simply given, I argue that all formal systems must presuppose a certain conceptual structure in order to function. So why do we need protologic? Actually, in terms of our contemporary discussions, protologic could us give insight about the nature of the logic. So as I mentioned earlier, most traditional approach to logic, whether realist, idealist, or conventionalist, assume that logical structures already given for us. But if we step back, we realize that this approach is fundamentally limited. Because formal logic, if it is to be more than an arbitrary manipulation of symbols, must be constrained by fundamental conditions that allow structured reasoning. This is where proto-logic comes in. So my main question is what are the necessary conditions for formalization itself? While explicit attempts to ground logic or the finding foundational logic rare, there are some philosophers who have tried to address this issue. I will briefly consider their contributions. Guillasher, in Epistemic Friction, discusses about the grounding to logic. And she argues that the world enables the logic and world grounds the logic as well. And she introduces foundations without foundationalism idea and attempting to balance foundationalism with coherentism. It's more epistemic approach how to ground logic. But it does not directly argue could there be a underlying or could there be a root logic which makes the logical systems possible. And her work presupposes concepts like world, truth, and the relation between the world and logic. She did not explain why they are necessary and how these already given concepts like the world and logic relates. And the second and more directly about my topic is the Medi's rudimentary logic. Medi in second philosophy argues that the cognitive foundations of logic through a naturalistic lens, and she introduces the concept of rudimentary logic, which reflects the basic structure humans use to engage with the world. What she terms Kant-Frege world, Kiev world, because this is like a hypothetical world represent an idealized structure where the properties and the relations of objects clearly defined, aligning with how classical logic structures our understanding of reality. So the Medi does not fully articulate the principle or the connectives or the basics of the rudimentary logic and leaving open the question of its status as a formal logic. And also she assumes that the classical logic is the cognitive capacity that we have to realize the relations between the objects. So she did not open space for the non-classical logics as well. And Robert Hanna, in the book Rationality and Logic, 2006, proposes a proto-logic that underlies all formal system. He connects proto-logic to the Chomsky's arguments, universal grammar argument, suggesting that the logical competence is an innate feature of rational beings. So he argues that we as a human has innate capacity, innate feature, an innate logical feature, which is some sort of weak classical logic. But Hanna does not specify what are the principles or what are the elements of proto-logic. He just mentioned the possibility of this logic. And also Hanna argues that some sort of weak classical logic would be the proto-logic. So the biggest problem about grounding the logic or finding a foundational logic is the methodological problem. I said transcendental method, but this is actually just the question of asking how. How is this possible? So it's labeled as transcendental method, but this is just asking the question how logic is given to us. What are the conditions to have some logic? So what must be true in order for logic to function at all? So asking transcendental question, asking the condition and the possibility of a formal logic is not easy, since we have plurality of logical systems. And if we seek a ground or an underlying logic, then it seems we don't have like a common logic or the common ground. But I argue that formal systems as a common ground for formal logics, because every logic has a formal systems. To start with, to start searching for underlying or the root logic, we can delve into the formal systems, not for a specific formal system, but how we as a human construct such and use the formal systems. So depending on that, I think the core of proto-logic will be the unitization. What is unitization? A formal systems and every formal language starts with symbols, entities that are manipulated according to rules. But symbols alone do not constitute a system. A formal system does not arise simply by having marks, characters, or signs. It emerges when these symbols are recognized as units, capable of being distinguished, combined, and manipulated within a structure framework. This process, which I call unitization, is the fundamental precondition for formalization. If we have just the marks that are not symbols for us, because to distinguish mark from the symbol, I have to define its borders. So I have to take mark as an unit to make that a symbol. So any symbol has its borders and it has its features regarding to distinguish from the other symbols. So this is, I call unitization. So without unitization, a set of symbols remains an undifferentiated mass, incapable of supporting logical operations. Consider, imagine a page filled with ink marks. Before we can speak of a formal language, we must be able to recognize some marks as symbols and distinguish one from another. Thus, unitization is not optional feature, but a necessary condition for the construction of any formal language. So I think we should start seeking proto-logic by how we take symbols as a unit. Then we can ask more deeper question, what must be assumed to unify symbol as discrete units? And this leads us to fundamental conditions of unitization. I think sameness, otherness, and togetherness are the three fundamental conditions of unitization. To realize, to conceive symbol as a unit, I, as a logic maker, we, as a logic maker, we have to realize that the symbols retain its identity. It is sameness. The recognition that a symbol is distinct from other symbols is the otherness. And the synthesis of the sameness and otherness into a structured whole is a togetherness. So I argue that without these three conditions, we will not even be able to recognize a symbol as a symbol, let alone build a formal system. So the same self, but also distinguished from other, but I have to think those two, sameness and otherness, should be together attributed to the symbols. I mean, if a symbol, let's think it as a thought experiment, we have sameness without otherness. So everything collapses into one indistinguishable entity. Every mark has its sameness, but if it does not distinguish from the others, then they are the same for us. So we cannot construct a multiplicity of the symbols, then we cannot construct any formal system, any formal language. So otherness should need it. And those two things, sameness and otherness, should be together approached to mark to make them symbols. So I think the act of unitization and the sameness, otherness, and the togetherness could be the basics of the proto-logic, and the proto-logic could be the precondition for all formal system, and unitization is a key for symbols to function. And this foundation can help us to explore which logical connectives and operations naturally arise. I mean, based on the idea that the act of unitization requires sameness, otherness, and the togetherness, we can argue that there is a proto-logic relying on these three concepts and the act of unitization. I have some thoughts on that, but it's beyond this presentation. So let me conclude argument in summary. Every formal logic is constructed through a formal system. Logical systems do not exist in isolation. They require a formal structure within which reasoning takes place. And using the transcendental method, we can ask how formal systems are possible. Rather than assuming that formal systems are simply given, we investigate the condition of their possibility. At the most fundamental level, each formal system consists of signs. However, merely having signs is not enough to construct a formal system. These signs must be recognized and structured as symbols. So unitization is the necessary condition for any formal system. And without unitization, a plurality of signs does not exist for us as logic makers. If symbols are not distinguished and structured, then no formal language can emerge, and therefore no logic is possible. So unitization itself requires three fundamental conditions: sameness, otherness, and togetherness. And these three conditions, along with the act of unitization, provide a starting point for proto-logic. And by recognizing that unitization is the precondition of formalization, we gain a foundation from which to explore the logical principles and connectives of proto-logic itself. So the next step is to investigate what kind of logical operations and principles emerge naturally from these foundational conditions. So in conclusion, proto-logic is not a new logical system in competition with existing ones. It is assumed precondition for any formal logic. And by grounding logic in the necessary act of unitization, we open a path towards uncovering the foundational logic that precede and enable all formal systems. Thank you.
Jillian, where's the other microphone? Please say hello.
So I was wondering if you think that written language is necessary for proto-logic.
No, I don't think it's necessary. We can think an imaginary, just in our mind, a formal system, but even for the imaginary signs or in our mind, we have to think symbols as a unit. So my core idea is still the same for me.
The symbols in your mind, would they be like visual symbols, or can they be like words that you hear in your mind?
I'm not sure. I'm not sure, but whether it could be, I believe that we have to separate them from one another to make it work for a logical system. So either voice or either a shape, either anything could be, but that could be separated from one another. So that's the main idea.
Ryan? You can just...
Yeah, I'll just... yeah, I was wondering, I mean, you mentioned at some point transcendental logic or transcendental, and I was wondering if you had thoughts on what the connection between your project is and Kant's project of transcendental logic, right? So a lot of the things
you're saying here seem to bear some sort of relation. So for Kant, right, transcendental logic investigates the possibility of having an object that we can, you know, what's involved in the possibility of having an object that we can grasp, right? And, you know, the core idea of that is we have to be able to think of the object as a singular thing.
Yeah.
And so I guess I was wondering what you took the relationship between your project here and Kant's project there, and if, you know, some of the principles that you know, are going to spelled out might have analogs in Kant's project, or if you could say some more about that.
Yeah, thank you. It's a great question, because the transcendental method and transcendental approach is mostly based on the Kant. And actually the Husserl criticized Kant about not asking transcendental questions about logic. So the Kants take our experiments as a given and analyze how this experience is given. But Kant did not transcendentally analyze how logic is possible, because Kant thought that the classical logic already completed by Aristotle, and he did not fully articulate how formal logic is possible. So Kant actually, as Husserl criticized, did not ask the transcendental questions about the formal logic. And Kant inspires me in terms of how he takes our daily experience and how analyzes what are the conditions for our experience. But I take that insight and apply it to the formal logic, because I take not our experience with the object, but our experience of formal systems. So we have the similarities about the methodology, and inspires me. Kant inspires me, but he did not ask the transcendental questions, and he did not make logic as problematic as it is.
Bogdan? Yeah, cool, thanks. This is very nice Saussurean analysis of the possibility of logic. I love it. But I think I have this feeling that there's something missing here. In the list of three things that you really need. I mean, just think of the way we use logical symbols, for instance, in a rule like conditional introduction. Something like, well, you proved P for some name A, therefore you infer that every X has P. Now that only works if that token A, which we call a name, a symbol, in a sense transcends its identity, and although it's a concrete token one way or another, it expresses some form of generality. And you can, make similar reasons, bring forth similar reasons in respect to sentential variables, predicates, whatever. So I wonder if, generality shouldn't be the fourth, and I would say the overarching condition for the possibility of logic, question mark. A kind of generality.
I mean, in my perspective, if we do formal logic as we do, we need to differentiate, we need to unitize every symbol. like the conditional also has to be differentiated from the other symbols in terms of its shape, maybe, but shape is not necessary. We can use another shapes, but either way, I have to assume it is as it is. I mean, it is as same itself to make logic works and distinguish from the others. So if I get it right, the core idea is still the same. So I'm not quite understand that why I shouldn't generalize it to the formal logics.
No, I think you should keep them. I totally agree. You know, sameness, which is the Saussurean idea that the symbol is concrete, is a concrete token in some sense of concrete, should be the otherness. Likewise, because without otherness, if you are Saussure, you don't get sameness. It should be the togetherness, that's basically concatenation, should be there, because that's how you form larger strings. But this seems to describe a language in general and doesn't seem to be anything of particular formal relevance to it. So I think maybe generality, again, the kind of generality that you see at play in, for instance, universal introduction.
Yeah,
might be useful. I don't know, I'm asking.
Yeah, I see the point. If this is just the insights and the beginning path of the proto-logic, but if we apply it to the principle or to the connectives, then I can argue for what are the main connectives or the main principles of the proto-logic. I have some thoughts, but I did not share here. Thank you.
Cool, thank you.
Sorry, Anthony, Bass, and Graham, but we'll have more opportunity to ask questions after the next session. So let's thank everybody one more time. JJ, are you here?
Yeah, thanks. Rashid, can I share my screen, please?
Yeah, let's try.
Thanks. I can't share it.
Okay, I'll make you a host. Try now.
Okay, thank you very much.
Perfect.
Okay, thanks very much.
This will be our last session of the day, our last talk of the day, given by JJ Joaquin, a paper titled "The Simplest Solution to All Deontic Paradoxes." Go ahead. All yours, JJ.
Thanks, Rashid. Thanks for hosting this and thanks for having me. Unfortunately, I was not able to get my visa on time. That's why I'm online. Okay. Deontic logic and meta-ethics have been a fascination of mine since 2003, when I was a lowly graduate student here in the Philippines. In particular, I'm concerned about the nature of model reasoning and the logic of obligations. Now, during the pandemic, I had time to work on some of my notes in Deontic logic, so I published some materials on this particular topic. In particular, the 2023 paper in simple solution to the deepest paradox of Deontic logic, and that inspired this whole presentation. Now, the target simple solution that I want to talk about here and to share with you is Hector Neri Castañeda's 1981 paper, The Paradoxes of Deontic Logic, the simplest solution to all of them in one fell swoop. This is a work in progress. I'm developing this as a full-blown proof system for just a celebratory aside, it's the 50th anniversary of Castañeda's Thinking and Doing. If you're aware of that, happy 50th anniversary. Okay, so here's the plan that I have. So I'll talk about standard deontic logic. By standard, I mean the garden variety deontic logic that we all know and love. I'll talk about some deontic paradoxes that Castañeda considered in his paper, his simplest solution, and let's try to assess the simplest solution. So here's the standard logic. It's just propositional calculus with some modal things going on there, plus deontic concepts of obligation and permissibility, which I'll use O and P for our purposes here. The semantics is familiar, I think, so it's a model where you have deontic worlds, relationship among those worlds, and evaluation function given those worlds. Now, we can think of deontic worlds as optimal or morally ideal worlds, some wishful thinking worlds, perhaps, and the relationship might be transitive, reflexive, symmetric, and so on, and the evaluation is always relative to the deontic world under consideration. So given this, you could define, at least in standard deontic logic, what ought is. So ought A is true if and only if the value of A is true in all accessible deontic worlds, and PA is true if and only if A is true in some accessible deontic world. Now, the deontic consequence will be just the absence of counterexamples. So B is a deontic consequence of A if there's no valuation where the value of A is true and the value of B is false in all accessible deontic worlds. Now, here are some truths that are interesting from the point of view of deontic logic. So you have the first one, you can't have inconsistent obligations. Sorry, Graham. Two, oughts distribute to conditionals. This one, oughts distribute to conjunctions. You can't have obligations to contradictions. You could always have obligations to the law excluded middle. These two here will be definitions of O and P. This one here, this thing here is the D action, for those who are familiar. Ought implies permissibility, a reduction thesis, and this weird thing there. Now here are some salient SDL rules that we'll talk about later, specifically this part here, but it's just a kind of necessitation rule if you're familiar with your modal semantics. Now given this, you could define other deontic concepts like A is forbidden as this, A is optional, something like contingency in modal logic, A is non-optional, something like this. And here are some salient SDL untruths. So you can't have facts implying oughts, you can't have permissions implying facts, and so on and so forth. Now on to the deontic paradoxes. Now these paradoxes are, I think, familiar to most of us, and I've arranged them in order of their publication. So first is Ross's paradox of obligation. Second is Arthur Pryor's Good Samaritan paradox, E.J. Lemon's Platonic dilemma, and we'll end with Chisholm's contrary to duty paradox. Now the main target of these paradoxes is this particular rule, where we could interpret it as a kind of thesis that an obligation's logical consequence is obligatory. So remember that, because that's the main target of these paradoxes. So here's the classic paradox of obligation from Ross. First premise, it is obligatory that the letter is mailed. So from here, you conclude that it is obligatory that the letter is mailed or the letter is burned. So for those who are into burning stuff, you'll like this paradox. Pryor's Good Samaritan paradox is also interesting. So first premise, helping a robbery victim strictly implies a robbery happened. Thus, if robbery is forbidden, helping a robbery victim is also forbidden. Now, looks good, but as you know, the conclusion seems off
given the premises. Oh, the premise. Levin's Platonic dilemma, I think is also familiar, and this one is coming from the old Plato dilemma about the poison. Right? So suppose it is obligatory that I return Brian's gun, given that I just borrowed it from him. It is also obligatory that I don't return Brian's gun, for example, because I know that Brian will kill someone. So thus, from these two premises, it is obligatory that I return and don't return Brian's gun. So you have premises and you're led to a contradictory conclusion. Finally, Chisholm's contrary to duty paradox. Again, this is familiar. Premise, a person ought to help his neighbor. Second premise, it ought to be that if the person helps his neighbor, he has to tell he is going to help. Third premise, if the person does not help the neighbor, then he ought not to not to tell that he's going to help. And finally, the fourth premise, the person does not help the neighbor, so that's the supposition. So given the logic, you'll have a contradictory or inconsistent obligation. Okay, so those are the paradoxes generated by standard deontic logic. Now let's see the simplest solution coming from Castaneda. Now to quote him, a cursory examination of ordinary deontic language reveals that the solution to all so-called paradoxes of deontic logic is stunningly simple and magnificently uniform. They can all be solved in one single stroke. That's why it's the simplest solution to all deontic paradoxes. So what's the simplest solution? Well, distinguish between indicatives and infinitives. Propositions from practitioners, as Castaneda calls it, and affirm the relativity of oughts in our deontic language or in our deontic logic. So let's see what this implies. So for Castaneda, no deontic logic worthy of its name that has some useful richness can afford to ignore the momentous duality within and without the scope of deontic operators. Namely, the duality entrenched in the contrast between an action considered as a circumstance, that is, the indicative proposition, and an action, perhaps the very same action, considered deontically as a deontic focus. So note these two things here. Okay, so what are indicatives? Well, indicatives for Castaneda are circumstances, which can include the actions performed. Think of this as facts that we know. And infinitives will be the foci of deontic operators. They are the infinitival elements performable by some agents who are subject to obligations, duties, etc. Just to get this going, here's a motivation. Consider a familiar academic scenario. An indicative, perhaps, as a professor, Alan Hayek publishes 10 papers a year. So that's an indicative. It tells you a fact about Alan publishing 10 papers a year, being a professor. Now, in contrast, you can have an infinitive and transform this sentence into a kind of imperative. So when you go to your chair, and your chair tells you, as a professor, publish 10 papers a year. So this part here becomes an imperative. This thing here is not an imperative, it's a declarative, perhaps a proposition. Okay. So this distinction being made here is between an action considered as a circumstance, fact, and an action considered deontically as a deontic focus. Now, this brings us to a distinction made by Castaneda between propositions and practitions. Propositions are actions considered as a circumstance, while practitions are the agent-action complexes that are deontic focus. So what do we mean by deontic focus? Something like this. So from an infinitive, like as a professor, Alan published 10 papers a year, you could put in the ought there and say, as a professor, Alan, you ought to publish 10 papers a year. Now from here, we could have a kind of logic. It's a logic that Castaneda developed in his 1981 paper, which distinguishes between indicatives, right? So it's a set of small letters, while infinitives will be the capital letters. You still have your logical connectives, and you have an index deontic operators. Now, for Castaneda, the formation rules of this kind of logic is as follows. So a connective compound of circumstance and deontic foci is also a deontic focus. On the other hand, deontic operators apply to deontic foci, whether pure or mixed, but the results, that is, the deontic statements that result are not themselves deontic foci. Now, that is, if you think about it in terms of SDL well-formed formula rules apply, but only partitions, or compounds having them as elements, can be within the scope of deontic operators. So something like, you could have a conditional like this with two indicatives, and you could have a conditional containing an infinitive and an indicative, and they are well-formed formulas in this logic, but only this part here is a deontic foci. That is, it's the only thing that you could be part of the scope of a deontic operator. Okay? Just a note about the deontic operator. So for Castaneda, deontic operators need some further modalities to produce those statements that are false. Well, this means that A is not fully true or false. It's not a fully true or false statement if I, the thing here, is not specified. So think of I as a kind of according to clause, something like according to law, or according to moral norms, or according to the signed contract, etc., etc. So only if we have this kind of specification for I would a deontic statement like OIA is fully true or false. Now this brings us to the relativity of OI. It just means that the subscripts are doing some work in the excuse me, in the assignment of the truth values in your formula. And I'll just quote him here. I have, Castaneda says, for over 2 decades been representing by means of subscripts attached to the deontic words. So he's been doing this for over 2 decades. Now here are some truths that you could get from Castaneda's system. So the first one is if it is obligatory for you to do A, then do A. So A here is not, again, indicative, it's an infinitive, and a kind of imperative. So this makes sense within a given specification of I. Same goes for the rest of the formulas here. Now, we have time to address the paradoxes that I have talked about a while ago. So here is Castaneda on Ross's paradox of obligation. To quote, it has never been entirely clear to me why paradox is supposed to be paradoxical. The best I can make of the allegation is this. The disjunctive order can be fulfilled by burning the letter, and 2, the disjunctive order and the disjunctive obligation leave it open to the agent which disjunct to fulfill. But a little reflection suffices to show that the strong interpretation of this one here is utterly incorrect. I think what he has in mind here is something like this. So you have this paradox, but if you think about it, the premise, that is the deontic foci, mailing the letter, right, satisfies both premise and the conclusion. But burning the letter does not satisfy the practive premise. So this one is not really that paradoxical if you think about what's going on in the argument. So how do we address Pryor's Good Samaritan paradox? Well, here's Castaneda again. The premise is a proposition Well, the conclusion is a practition, since there's no bridging premise from the propositional premise to the practitional conclusion, the argument is invalid. How about Lemon's Platonic dilemma? Well, if you think about it, the obligatory operator or the deontic operator in the premises are from two sources. The first one is according to contract, and the other one is according to some moral norm. Thus, the conclusion does not follow given Castañeda's logic. And finally, here's Castañeda on Chisholm's contrary to duty paradox. Quote, the so-called Chisholm's paradox of contrary to duty imperatives is just another variation of the problems created by the failure to see that the ontic operators sometimes operate on propositions that have both propositions and simpler propositions as proposed. Okay, so that's the solution, the simplest solution. And for Castañeda, this simplest solution provides the easiest and most uniform way of preventing the alleged paradoxes from arising. The calculus is furthermore not only stunningly simple, but also very comprehensive. As we have seen, it can solve all these paradoxes in a single truth. Now we can extend the simple solution to other sorts of paradoxes, like Scotch and Jennings' revised Good Samaritan paradox, activists' paradox of epistemic obligations, and Forrester's gentle murder paradox. I'll just run through them. So here's the revised Good Samaritan paradox. It's a funny paradox to think about. We ought to feed starving children, a bridging premise. If we ought to feed starving children, there ought to be starving children, so thus there ought to be starving children. That's a weird argument. And here's this paradox of epistemic obligations. Alan ought not to do A. You ought to know that Alan does or did A. You know that Alan A does or did A strictly implies Alan did A. So this is the famous knowledge to truth premise. So Alan ought to do A. And here's the gentle paradox. I'll just let you read it for a while, but the key thing here is this part here. Okay. So the general Castañedan response will be to say that these paradoxes are ill-formed. The ontic operators apply to the ontic foci, not propositions. So as you can see here, the revised Good Samaritan paradox has that mistake of putting the ought to some proposition, not a practition. Same goes here for the active paradox. Well, for the gentle murder paradox, the paradox is simply invalid because, again, this one, without even using Castañeda, you'll see that this one's an invalid derivation. Okay. Now, you might object that the whole thing, the Castañeda thing, confuses ought to do and ought to be deontic statements. Perhaps we could have a kind of reduction. We could reduce I ought to do A, which is the deontic foci, to some kind of ought to be sentence, like it ought to be the case that I do it. So you have a proposition, and it's equivalent to this kind of practitioner. Well, here's a repost. Well, the equivalent sometimes fails. So there ought to be starving children. This is equivalent to we ought to starve children. Obviously, I hope that's true. Alright, how about agentless obligations? So there are some obligations that don't have agents, like every car ought to be licensed, the world ought to have been without pain, and so on and so forth. Well, here's Castañeda's rejoinder. He leaves it undecided whether the ought to be is reducible to the ought to do or vice versa. Well, notwithstanding that agentless obligations, like every car ought to be licensed, can be reduced to an agential one, like everyone who drives or owns or manages a car ought to get a license for it. Here's the final retort, perhaps. We could do away with practitioners, because the simplest solution is not that simple if it has practitioners on top of propositions. Can't we just dispense away with propositions and reduce them to propositions? Well, here's Castañeda's defense. The unity of practical thinking is immediately accounted for by taking prescriptions and intentions as complementing each other in one category of propositions, category of propositions. And this duality has helped solve what we have seen, the so-called paradox of the Good Samaritan, paradox, and so on. So here are some final thoughts. I'm not sure if you're buying the simplest solution, but I think it's a formidable solution to all of the ontic paradoxes. Thanks very much. Indicatives or propositions and infinitives lead to a kind of multiplication. So why not reduce one to the other? So you'll have a more simpler logic. But I think the defense here is, since this kind of logic, this kind of infinitive/indicative logic could provide solutions to the ontic paradoxes, then perhaps that kind of multiplicity is okay if it can solve all the paradoxes that we have seen here. We can generalize this, by the way, to other sorts of ontic paradoxes, like the free choice paradox and the second best plan paradox. So long as there's a confusion between indicatives and infinitives, then yeah. But the point about the relativity of ought is also something interesting, because perhaps there's a big norm, like what moral realists would say. There's the facts, the moral facts out there in the world that you should ground all your deontic reasoning. But I'm not sure that the Castañeda system can accommodate that kind of moral realism, because again, you could have oughts, you have like Venn diagrams or order diagrams that here's a small ought, it's included in a big ought, and so on and so forth. So you can still have a kind of relativity, albeit there's a kind of absolute ought in the vicinity. I hope I answered your question, Joy.
Okay, thanks.
Let's thank
Thanks.
JJ one more time.
Thanks, Rashid.
Thank you. So we're gonna head to Al-Mubarakiyah. So whoever wants to join, we're gonna hop on the bus, hang around.